Hey, what's up, guys? Greetings of the day to viewers of this video, and welcome back to ptscadexpert and myself, Architect Kumar Kapadia from the city of Surat in Gujarat. And for this course, Master Diploma in Revit, complete live BIM course, which is a combo of architecture plus structure plus MEP. For architectural segment, if you just go to YouTube under ptscadexpert channel, under playlist section, you will find a playlist Revit BIM with Dynamo, wherein a lot of video tutorials have been enlisted which follows the modeling of a typical residential structure with perfect precision and perfect joint condition. For example, if I talk about this particular project, this villa design project, it follows architecture plus structure following the level of detail LOD 400, which shows the modeling of a typical structure exactly in the same way a structure is elevated on site. That is, how is a column elevated from footing and joined to beam and floor, and how are all the structural elements joined to architectural elements wall with all its wrapping layers and perfect joint condition. So if you want to enhance your modeling skills with Revit, then kindly enroll for this particular course and let's learn together and let's grow together. But today's exercise is going to talk about modeling of this typical G+4.5 low-rise residential building, which is not going to take into consideration the structure part, but we'll talk about the modeling skills with Revit, that how efficiently and prominently you can model 3D elements in Revit with perfect precision in stipulated time frame. Wherein if I just take it to the floor plan, AutoCAD drawing of this particular project, then this is the typical floor plan of that particular project, which if you just elevate following the footprints, then this is the end result and you'll be able to create this particular building likewise without any elevation treatment. But as an architectural designer, I have manipulated the floor plans at several levels in order to get the massing and elevation treatment, which will create the end result to be this. So now, without wasting a single second, let's start with the modeling of this particular simple G+4.5 residential structure, wherein we are just going to encounter that how can you use different modeling skills with Revit, and how can we use the different modeling techniques with Revit with the use of how can we create the different assemblies. For example, if I just take it to the structure, the assembly of this particular wall, then you see that this is the wall which follows different layers. Okay, and the total thickness of which is 2 feet. So we are just going to start with all of this. Now, without wasting a single second, I'll just go to this particular file and new, and I'll just open up a fresh new project environment template file, wherein RBT templates, and we will follow the imperial system for this particular project and default. And I'll just open up a fresh new project environment and fine. So using the functions of Revit, what I'm just going to do is that I'm just going to go to manage, and herein I'm just going to go to transfer project standards, and I'm just going to copy certain standards, established standards from that particular project, so we can concentrate on the modeling part. For example, I will just say that I want the wall types, I want the materials to be copied, I want the floor types, different floor types. Where are the floor types? Yes, floor types and curtain wall types. And where is it? Yes, curtain wall types. Okay, and with this much, I will just say that okay. So you see that all the details, which I will essentially show you that how to create it. But just to save time, I have copied all the details from that particular project to this project. And in this particular fresh new projects, if you just go to this material section, then you will see that all the materials from that particular project have been copied here. See, all these are the custom materials which are made by me, and I will show you that how to create this particular materials. Okay, and likewise, all the other details have also been copied. What we cannot copy through project transfer is the door windows. Fine. So I am just going to select this particular parametric window and open that. And from herein, I will just select this particular door, open up that, which you cannot transfer but you can just open and load it into the fresh new project and use that particular element from project to project. This particular sliding folding door window. Okay, and what else? This particular door, I guess that we have opened it. Yeah, we have opened that particular door. So what is left is that, yeah, this will already this particular window comes with the inbuilt library of Revit, but this particular door and also this ventilation will not part of that particular new fresh new project. Apart from that, yes. So we have copied all the details. Fine. So we can now concentrate on the modeling part. I'll just particular close this project, and from this particular open families, I will just load this into the fresh new project. Okay, and just close this. Also, I will copy this door. This will take a bit of time because all of those 3D elements are complete parametric. And this is sliding folding door window. And close this as well. No, this is single door, single panel. And last one is this Lowrise, which you will find in inbuilt library of Revit also. I'll just load that also into the project. Fine. So with that, I will just come to this particular fresh new project. And if I just go to architecture and doors, you will see that all the parametric doors, which are part of that particular project, has been copied. Okay. And also if I just click this window, then too, all the windows have also been copied. Fine. Okay. So now let's start with the modeling of this particular structure. And before I lose, let me just save this particular project and go to desktop and just save this, calling it live project April 25 for students. You will get this particular project and also the AutoCAD drawing of this particular project. Don't worry. So after saving this particular project, now the first step that follows is that come to the south elevation and create different levels. So this would be essentially ground level. Yes. And this would be first floor. Okay. I will just click LL. And with this snap, I will just say that with the offset of 10 foot, I will just create 1, 2, 3, and 4. Wherein this would be second floor. And this would be third floor. And this would be terrace plan, terrace level. And this will be slab top. Yes. Fine. And if you're using Revit 2025, then this particular level will be with this black and white annotation saying that these are not part of this particular project browser. How to make it authentic? Just go to view and under plan views, just go to floor plan, select all of them and just click OK. And reflected ceiling plan, select all of this, OK. And if you want structure, then for structure, all of them are not true. But anyway, we are not going to take into consideration structure part, so that's fine. And now if you just see this particular, then right now, the hierarchy is not getting followed, and all the levels are staggered. So I'll just go to the particular view and just get a browser organization. And herein I'll just say that new and by level. Okay. And come here and grouping and sorting, group by family and type, sort by associated level, and just click OK. And select that by level and just say that OK and apply. So now you see that except for this particular floor plan wherein the site is hanging around, so that's fine. Don't just ignore that. Ground followed by first, followed by second, third, and then finally terrace and flat top. So that same followed for this particular ceiling level. Okay, so now I'll just go to the particular ground level, and herein I'll just go to insert and import CAD, and you will get the AutoCAD drawing also. I'll just navigate to that particular location and live project April 25 batch. So since this particular drawing is in feet inches, so here the colors preserve, layers all, and your import unit should be inch. And I will just say that manual center and just say that OK. And this is how we have imported the AutoCAD drawing into the Revit environment. And I'll just go to VG and come to categories, import its categories, and turn it to halftone. Fine. So let's quickly begin with the modeling part. And I will first start creating different floor plates. So I'll just go here, floor, and floor architecture. And herein I will just select, we have already created, we have transfer project settings. So we have all the details established. And this will be entrance, I guess, entrance pathway. Yes, here it is. So it is a floor of 6 inch, which has been assigned this particular material pathway. Fine. It is the existing material of Revit. So if you want to create new material, you can just say that create new material. And from here, let me just show you how to create a new material. So 64, yeah, fine. So here there are a couple of ways to create different types of materials, wherein you can just use this AEC materials and make it a part of this editor. And if not that, you can just say that here, create new material, and I will just rename this one PTS material, wherein you can assign any of the color if you want. And if not that, you can just go here to this asset browser, and under that appearance library, and under that you have lots and lots of pre-established materials made by Revit, from which you can select your required category. For example, the one which I just showed you belongs to this masonry, and under that is some of this, any of that particular material. Oh no, sorry, it was from site work. Yeah, fine, site work. And under that, this particular payment, crossway, walkway, you just need to replace that material with the current edit. Replace this material in the editor and just say that finish. Yes. So it has been replaced. So it is now here. Okay. But when you replace that asset with this asset in the current editor, what you need to do is just go to appearance and don't forget to duplicate it, because you're going to make changes within the tiling of this. So if you make any changes, that shouldn't reflect in the library of Revit. Okay, so this was one way. Or apart from that, as I said, from here AEC material, you can select any of this existing material and make it a part of this editor and duplicate it and use it. Okay, so that is how. I'll just press escape, and with this pathway material defined, I will just say that apply and OK, and I will come here and start drafting. I will come halfway. Okay, and just say that pick lines 1, 2, and 3. Split PR and join this to this and join this to this. Okay, and herein I just use LI and have a close shape. Split this as well. PR join this to this and join this to this. Okay, so we have made one. I'll just say that finish, and with that I'll just say that CS, that is create similar, but this time I will select a different floor plate which would read parking quota. Okay, and edit type, and it is also a slab of 6 inch but has been assigned a different material. So this is a custom material which I have downloaded from Google. Thumbnails, and yeah, which was that? Yeah, this is that particular material which I have applied to the view. Okay, So I will then say that again rectangle, and from here to here, I'll just say that pick lines 1, 2, 3, and just say that split. Join this to this, join this to this, and just finish. Again, I will say that CS Credits Villa, and I will select this parking and go to edit type of that, edit, and that has been given the material of circulation. Actually, I should have renamed that particular floor plate from parking to circulation because we are going to use that at another different places also. But this is the JPEG commits that have been applied to it, giving it a tiling of 6 feet cross 8 feet. Okay, apply and OK. And with that, I will just create one complete rectangle. OK, and just say that finish. Fine. So this is how you create different materials. And if I just press realistic or enter, then you'll see that a project has started breathing. Fine. So I again press H12 so we can see the AutoCAD floor plan. And now we will start elevating this particular structure. So first I will just go to wall, and herein I will just select this main wall 9 inch, and I just go to edit type. So this is nothing but the assembly of wall which contains this core, the structure between two core boundaries, and that I have set to 9 inch typical 230 mm, 0.23 meters, 23 centimeters, but that has been applied this wall concrete texture. Okay, it is also an existing material of Revit which I have loaded here from asset library only and replaced it. And once replaced, I have renamed it. Okay, so wall concrete texture, and that's fine. This is the material, apply and OK. So these are the wall which we are going to create. So I will just start drafting from here. Let's say that the finish with exterior is the location line from here to here and from here to here. And you see that this is the internal wall. So I will just select this and go to internal wall 4.5 edit type. That has also been given the same material, but the only thing that the thickness is 4.5. Okay, and from here to here. Fine. I will just select all of these three walls and say that the base constraint to be ground floor, and straight away I will take all this particular walls up till slab top. Okay, and here this wall I will leave it as it is because this is going to be a special wall. Then I will again say that wall and select that main wall RCC 6 inch edit type, which has been given the thickness of 6 inch and it has been applied the material of this particular concrete. Okay, so again ground floor up till terrace plan. Oh no, slab top, sorry, slab top, and just click from here to here 1, 2, and 3. And this internal wall, I will just CS with same constraint from here to here. Okay, so that is how I have created this lift shaft. And now I will just go to this particular stairs. And this monolithic from ground floor to first floor with desired number of risers. How many of them? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19, 20, 20, 21 of them. So that would make the actual riser height 5 inch and some ugly fraction. That's okay. And the actual tread depth is 1 feet. Yeah, it is 1 feet. Okay. So I'll just say that run. And with that, and this is how much? 4 feet. So run, and the actual run width, I will just turn it to 4 feet. And the location line, I will just turn to, let's say that we don't want the support system and the railing as well. So I will just say that railing to be none. Okay. I'll go to edit type. And for support system, yeah, everything, right support, left support, everything is set to none. And that's fine. And okay. And with run left, I will just actually run right. Yeah. So start running, create, and then I will just create over here and create over here. Okay, but one thing I forgot, that within this particular run type, the structural depth of this 2.5, that's fine, but I would just get rid of this particular slanted. Okay, yes, and concrete cast in place gray, one homogeneous material, structural depth, apply and okay, apply and okay. And with that, here I guess that there is some mistake. Move it and move it from this position to this. Yes. Okay, let's redraft it. Run and run right from here to, why it is not exactly selecting the point. Yeah, you need to check the snap point. That should be perfect. Then only it will snap. Okay, and again press tab a couple of times until you find the snap point. So 1 to 21, and that's fine. I'll just say that finish, and let's go to 3D. CC. Okay, and you see that the shaft had the lift shaft is there, and at the same time you have this staircase which is going from. Okay, and herein I will just come to this particular staircase, edit type, and go here wherein the monolithic material is cast in place gray. I will just click this, and since we have copied the material, so I would be having the stair material. See, so that is just a simple color which I have assigned. Okay, with bump. So let's say that stair material, apply and okay, apply and okay. But that has only been applied to flights. We also need to select this landing. Here it is, and that same material to that as well. That is stair material, and okay, apply and okay, apply and okay. That's fine. Okay, so that is how we have created so much part. Now again, let's go to ground floor and let's start constructing the columns, which in this case will be constructed with the help of wall only, since we are not taking into consideration the structure part. But we will follow the ideal process, wherein at this particular level, that is at first floor, wherever required, we will draw the beam network. If I just take you to this particular project, then herein you can see that despite the structural not taken into consideration, the modeling part follows the ideal construction, wherein you see that all of this walls has been given the base offset of ground floor to be 8.6, which says that this particular wall has been elevated below this level 18 inches, which will act as a beam. Clear, everybody? So that is the process which you are going to follow. For example, if you just see this particular thing, main wall, see the base offset is 8 foot 6 inches, and the top constraint is first floor with the top offset of 6 inch, which would make its unconnected height 2 feet. So from that 2 feet, the 6 inch will act as a purdy for the floor above, but this particular depth 18 inches will act as a beam. Okay, so that is the thing which we are going to follow. I'll just minimize this, that I have kept it open for reference, and just go to ground floor, and herein I'll just say that wall and just say that main 9 inch ground floor to first floor, and I'll just say that one, let's tab, and what I will do is that sorry, I just click wireframe so that we can select this column, this wall, find the snap points, and wherever you find the same orientation, just snap it. And 3, 4, and 5. Press tab until you find this snap point. So that is how you will place this. Okay. Yes. It's okay even if you snap to this cross, but just to be sure that we don't end up snapping to somewhere else, it is important to find that particular snap point. Okay, and now I'll just select put it one over here select this and rotate it and change the orientation. With that, I will just move it from this point to this point until I find the snap point and copy it again. We have a couple of them over here also. Okay, so this is how we have laid, and we have laid the columns. Okay, now we need to draw the beam network for the floor plate above. Fine. So for that, what I'm going to do, I'm just going to go to ceiling plan of ground floor, but nothing is visible. Actually, these columns are visible, but I need to see the footprints of the floor plan for reference. So what I will do, I will just go to this 3D, and herein, let me just first turn this to half tone. Okay. And herein, I will just turn this to the work plane is ground floor. I will just turn it to first floor with offset of -6 inches. What that will do is that if you now go to ceiling plan of ground floor, you'll be able to visualize the AutoCAD floor plan, which again, I will just go to VG and turn it to half tone. Okay, so now with this, what I will do is that I will press LI and find a common point. So I guess this this is the common point. So herein, I will just select this particular point and draw a line wireframe, and I will not be able to draw a line, but I will be able to draw a reference plane. Okay, RP, and with that, I will select this particular drawing and move this particular drawing and snap this point to this point. Or actually, we could have done that by align also. Okay, how silly. Fine. So I just press undo, and with that, I'll just say that align. And instead of this, I just draw RP reference plane and just say that align. Select this and just snap this face. Okay. So that is how CC we have snapped the AutoCAD floor plan over there. So we can have a look for this particular beam network. So I will again select this main wall 9 inch and say that CS, that is create similar. But this time I would say that the base offset. But before that, let me just change this view range. Let me escape out and just change the view range, wherein the associated, the cut plane is at 8 foot 6 inches. So if we draw anything, we are going to draw the beam which will have a base offset of 8 foot 6 inches, and the cut plane is at 7 foot 6 inches. So we'll not be able to visualize that what we are drawing. See, I just click wall, and if I say that the base offset to be 8 foot 6 inches, okay, and top constraint to first floor with a top offset of 6 inch, or let's say that 0 for now, okay, and with that, if I draft, we are able to visualize. That's great. Let me just check. Oh, sorry. Absolutely sorry. This is a ceiling plan. Yeah, fine. Sorry. This is a ceiling plan. So you'll be able to visualize. So fine. Let this be because the cut plane ground floor and the top is first floor. So that's fine. Okay. So with that, I'll just click wall and 9 inch ground floor, 8 foot 6 inches with the top constraint to first floor. And from that, I will just start drafting this beam network. And from here to here. And from here, this is also a category of wall. So it might overlap. That's fine. We are drawing the beam network. Okay. And wherever required, we will elevate that particular beam 6 inches to the floor. I will just click this and finish this here because this particular part we will need to elevate 6 inches high. And this I will snap it this here, this entire beam network over here. again this. You see, when such thing happen, you need to switch the order. So wall join and disallow join, or not disallow, switch order. I snap to this. Yeah, fine. So with that disallowed, see, I'll just click undo, and this is the case. So even if you click the point, snap point, and select and snap it at the perfect location, it will snap. So likewise, all the places where it has occupied the space of the column, everything it is perfect. See here. Here, if I just click this and just snap it, okay, so this is fine. So this are couple of tips and tricks to have the perfect draw order to avoid confusion. See, I will just say that this is now joined. This is only meant for architectural modeling purpose. For when it comes to the actual structure elements, then again the detailing part or the modeling part is different. Okay, and I guess that I need to say that disallow. Yes, and then I will just snap this. Okay, so with this now I will just conclude this here and CS and join this to this. Yeah, fine. Okay. Okay, again CS, come here. Okay, and draw this all the way till this point, and we don't have any column, so that's fine. This to this, and again this to this. But here, see, this particular wall CS that should be drawn only up till this point. Okay, and again then start from here to here. Okay, so you see that this is the dominating or major wall. Okay, and with that I'll just say that CS create similar and draw this, draw from here to here and here to here. Here also we have a column. Okay, and from here to here. Again, I will continue from here to this particular point. Okay, and from here to here. And this from here to here. This from here to here. Join this from here to this point. Yes. Okay. And okay. See, here also we need to switch. So wall join, and this junction disallow join. Okay. And make this perfectly snap. Okay. And with that, now from here to, or actually this is not needed. I will just conclude by drafting this and this. Okay. That's done. Again, here there will be a box wall. So I will just come here and say that disallow join. Snap this exactly here and snap this to this point. Okay. And now if I just go to 3D, you see that the entire beam network has been drafted. Here, I guess that I forgot to, let's go to ground floor. Yeah, yes, so this particular beam. So just say that CS and connect this to this. Okay, and this one entire is left. So CS and draw from this point to this point. Okay, again, yeah, fine. So this is okay. This is perfect. Okay, so this is the tentative. I will just say that CS and create from this point to this point as well. Okay, because there will be a wall above. So all the structural considerations and all these considerations are pretty much basic and conventional, which might vary from designer to designer. I'm just explaining you the ideal method or ideal modeling process. Okay. So now if I just go to 3D, then you see that entire beam network of the floor plate above has been completed. Okay. With this, now we can draft the floor plate, and wherever required, we will take this particular walls above. But let's first draw the floor plate required for this particular first floor. Okay. So here I will just select this AutoCAD floor plan and just say that base offset to be 0. So with that, I'll just close this ground floor ceiling plan. And if I just go to first floor, you'll be able to see that your AutoCAD drawing is putting up at now at first floor with that, okay, with the 3D elements visible here, okay. So herein, I will just say that architecture and floor architecture, and just select the parking or circulation. And let me just say that edit and rename this, call this parking dash circulation, okay, which will be having this circulation material, okay. The floor plate will have the material of circulation, and herein I will just drop this from here to this point, and I will just go to and 1 to 2 and 3, 1 to 2 and 3, connect this with this, join this to this, okay, and with that I'll just say that finish, and let's go to 3D. Okay, fine. And if I just come here to first floor and take a section, let's just see, then you see that it's perfect, absolutely perfect and modified. And you see that this is 5 inch and some ugly fraction, but anyway, the staircase is reaching up to this particular level. Okay, just delete this particular section since we don't need it. And first is, let's just complete the modeling part of this particular wall, this particular special wall. So for in that case, I will just go to let me just select this staircase and this passage and this staircase, and just say that use this function, very powerful function, copy to clipboard, and just say that paste align to selected levels. I will say that place it at first, second, third, and just say that okay. Oh, sorry, by mistake I selected the wrong. So just say that copy to clipboard and align to selected levels, and not to first because it's already there at the first level. So second and third and terrace, and just say that okay. So that has been created, but again there is a mistake. Why am I? Just say that with that selected, align to selected levels, and first, second, third. Okay, yes, fine. Okay, clear. So that particular thing has been created, and staircase is going from ground floor up till this particular this level, and this is terrace plan. So this is the terrace level. Okay, and this is this laptop. Now let's construct that special wall. So I will just go to ground floor, and herein we don't have the reference. Yeah, fine. Okay, let me just go to first floor where the AutoCAD plan is there. Okay, and I will just say that this is going to be the box wall, the entire box wall. Let me just take you to this particular floor plan, this drawing, this 3D, and you see that this is the box wall, which is having its thickness to be 2 feet, which has been achieved by adding all this particular layers, wherein we have this cavity layer, air of 10 inch. Okay, and this is the brick cladding. So this is the interior layer, and all these three are the external layer with the core layer of structure of 9 inch in the center between, I mean, in the center between these two boundaries. Okay, so we have already copied that wall. So what we just need to do, just say that wall, and herein I will just select that particular box wall. Yeah, here it is, box wall, edit type. So see that same wall, purchase order here also, wherein this different layers have been added. Let me just show you. Let me just say that delete and delete. Okay, and delete. Fine. This is the core structure layer with that material of wall paint. This is the material of the wall paint which has been added because that layer is anyway not going to be seen. So no point applying this wall concrete texture to that. So material of wall paint, and then I will click here and just say that insert 3, which all of them will be finished for. Copy and paste. No, sorry. This would be the thermal air layer. This will be the cavity layer. Okay, and actually the cavity layer will be, even I forgot. Pardon me, guys. Yes. So herein, if I just go to the construction part of this, edit. Yeah. So the thermal air layer, and then followed by this finish 1.4, and then finally the brick cladding. Okay, yeah, fine. Sorry. So this would be the thermal air layer, which will be followed by finish 1.4. So thermal air layer of 10 inch, which will provide the cavity. Then we have this finish 1.4. You can apply it any material, but this layer has to be applied the material of air or air infiltration barrier, whatever. I will just apply it a material of air, which I will just provide, and then finish 1.4. This could be again the wall paint because anyway that is not going to be seen. This would be on the 4 inch, and this is going to be the external most layer, which is going to be the brick cladding. Brick cladding, I guess one, yeah, brick cladding. See this, wherein this is the existing material of Revit, which I have applied it from here only from asset browser while going to the brick category. Under appearance library, you have this masonry work and you will find it under that. Okay. And I have just, don't forget to duplicate. And within the tiling, I have given it a sample size of 4 cross 4, 4 feet for 4 feet. And I will just say that, that brick cladding. Okay. That would be only of 1/2 inch, the wrapping layer. Okay, and likewise here to insert and down, that would be essentially finished to 5, and the same layer copy, control C, control V, that would be of the 1/2 inch. So that would make the thickness of this particular wall to be 2 feet. And just say that okay, and apply and okay, and draft that wall from here, from this point, location line to be finished with exterior from this point to, but what is the base constraint? Let's keep the base constraint to ground floor with the offset to 0, and the top constraint to slab top with the top offset of 15 inch. Why this 15 inch? That I'll explain later. And from here to here, I will just create that particular wall. Okay, and if I just go to 3D, then you see that that particular box wall has been created. Only problem is that it has joined with this corresponding wall at this edge, on this edge. So what you need to do, you need to say that at each level, you need to come here and say that wall join, and just say that disallow, and snap this here, and snap this to this point. Likewise, go to first floor. Okay, that's done for first floor, second floor, third floor, and terrace plan. That's fine, perfect. And let's go to 3D, and now it is perfect. Clear? Okay, so that is how we have created this particular box wall, but now we need to manipulate it in a such a way that we would have this particular curtain wall, which would act as a glass wall for the intake of light and for elevation purpose. So you see that we need to manipulate this. If I just select this and H, we see that all this level at this particular thing, if I just go to edit profile, this has been manipulated depending upon the floor plates, that from here few distance, and from here the few distance, and this particular cutouts, producing this particular cutout, and then snapping the curtain wall on the exterior face of that. Okay, R enter. So we will just do that real quick. Let's go to this project, and here I will come here to any of the floor plan, take this particular section and just flip it go to that particular section, and here is that particular box wall, and we have all the levels for reference, so we can manipulate that how to edit this particular wall in a such a way that we would have a cut in the center. Let me just check once that how much is, let me just go to any of the floor plan. Let's say that first floor, how much is the distance that I have left from both this modify, and this is 1 feet 6 inches. Yeah, that's fine. Okay, 1 feet 6 inches on both the sides. So I will come here and just say that edit the profile HL. So you are in the drafting mode, and with that I will just say that offset it. I will draw a line. Let's say that this is the top, and this is that particular face where we are going to lay the slab top. So I will just create a line over here and drop it 18 inches from there. This is how you draft out and create a line. Oh, sorry for that ugly sound. And move this 18 inches and tr without, before, just say that dm mirror it. Okay, and just join this to this and join this to this, and here at all the floors we will have a room of 9 inch, and this would be the cutout at each space, and CEO at each floor. So CEO, and copy this to this from here to here, here to here, and likewise from here to here. Okay, clear? And just say that finish. So with that, we have manipulated this particular wall, creating cavities and the space, because we are going to lay the curtain wall here outside. So if I just go to ground floor and let me just check whether that curtain wall exists. Curtain wall, yeah, see, curtain wall, stairway for box wall, that has been copied from that project. But if I just go to edit type, then you see that this system panel is reading glaze for option A, curtain wall. This is something this you don't need to worry about. This can be system panel glaze, essentially. Okay, just to make that the glaze that comes with Revit is not dark, and I wanted a dark glass, so I have just created a different glaze wherein I'll just show you. See, this is the let me type glaze. So see, within this curtain panel, you have this glazed. So Revit will always reference this by default, which has the material of glass that is provided by Revit. Okay, so this is that material, the standard material of glass. But I have duplicated this, and just if you go to type properties, then it is nothing. Everything is perfect, but same. But this material dark glass has been referenced there. Okay, the material of glass has been referenced to this with which dark gray shade. Okay, so that is only change within that. So I will just say that wall, architecture and wall, and this curtain wall, stairway for box wall, which is referencing that glaze, that particular glaze with dark glass, and this vertical mullions are saying that all these mullions are 1.5 cross 2.5 for this particular box wall. Okay, but I am not going to divide it on the basis of this vertical grid or a horizontal grid. First is that I will just lay this, and from this point to this point with the base constraint to ground floor and base offset to 9 inch, and top constraint to first floor, not first floor but slab top, but top offset to be minus 18 inches, and that will properly perfectly occupy and reference that. Press space and just go to 3D. Okay, clear everybody? So this is how you reference a curtain wall, and I will just select this curtain wall and go to this 1.5 cross 2.5 mullion. So this mullion I will just select and go to edit type, and I will reference an existing material of Revit Sash. So this is that existing material Sash, which comes with the every project environment of Revit. Oh, too fast. Sorry. Sash, and just say that apply and okay. Okay. And now with that, now you can manipulate this particular curtain wall, adding horizontal and vertical divisions. How? I will just go to this particular section, CC. I will select this particular curtain wall and just say that HI. Okay. No, not HI. We will need this particular thing for reference. I'll turn it to wireframe. But what I will do is that I will select the staircase and hide in view, or let's say that temporary hide. So select this eyeglasses and hide category. So the floor plan is, the drawing is little bit, and also I will hide this walls HH. Okay, and hide this. Okay, so we have now this particular curtain wall which you can manipulate hidden lines. And now I will just go here and say that curtain grid, and I will just divide this particular grid vertically, laying 2 feet 6 inches on this side and 2 feet 6 inches on this side. Okay, and likewise I will again say that curtain grid and divide this horizontally as well in order to place the mullions. But for that I just need to turn it to wireframe in order to see this beam network. Okay, or the way we have made a cutout within that particular wall, CC. Sorry, wireframe, WF wireframe, and just say that curtain grid, and randomly just create this grid such that it match this division 1, 2, 3, and 4, 5, and 6, 7, and 8. Oh, I made a mistake for this last one, 8, and likewise. Okay, so with this grid created, now what can you do is that you can just go to this mullions, and that's with that same mullion 1.5 cross 2.5 rectangular for box wall, edit type, which has this material of sash which we just applied. I'll say that all grids, and just click this, and just with one click all the mullions has been placed to that particular division that we created. If I just go to 3D, then you see that your curtain wall has been created with that mullions place, which is not exactly following this. If I just go to 3D, then you see that there are a couple of vertical divisions which I have placed here. Okay, but the horizontal division remains the same. So let me just show you. If I just say that curtain grid, I can still more provide the vertical segments over here. But since it has been manipulated, so I need to go to section 1, and let me just 1 and 2. I'm just randomly adding. Okay, and just say that mullions and grid line with one grid line 1 and 2. Okay, and let's just go to 3D. Okay, so this is how I've created that particular entire box wall which is having this cavity, and the curtain wall is snapped with the horizontal and vertical divisions for the intake of light and for elevation treatments. Clear? So we are done with this much part, and now let's proceed further with the modeling part, wherein we are first going to lay the floor plate for this particular first floor. So I'm just going to first floor. Okay, and here the AutoCAD plan exists perfectly at the place where it is supposed to be, and I'll just click this FA. Fine. So herein the various different categories has been designed for floor plates with that particular project standards, but there is no rocket science within that. It is just a floor plate which is having a 6 inch of thickness, but has been applied different materials. For example, this public area, if I just click, then it has been again applied the existing material of Revit, which you will find it under appearance library under this masonry. Okay, you will find it here only. I have applied it from there. So you see, it's really that type masonry, and but it has been given the sample size of 10 cross 10. Okay, and with that, now CC but actually, in order to place that particular floor plate perfectly, I need to see the beam network which is at the floor below. So I will just cancel this. Yes, discard this particular floor, CC. And this is actually the AutoCAD plan. If I just H, yeah, fine, okay. So see, the beam network is visible. The beam network is visible. We just need to pay attention while drafting the floor plates. So FA, and first would be the public areas, and I'm just going to click the rectangle, and this would be one. Okay, and here I have to select this edge because beam is up till here. Okay, and anyway, this floor plate is going to go below this level, 6 inches below this level. See, whenever you will put any of the floor plate, the level on which you place it, it will go beyond this, below this particular level. Okay, so storeroom would be the same. Here we have a beam, so that's fine. And from here till here, okay, living room and kitchen dining. Here we have a beam as well. And this LI, I'll eliminate this much and just say that split TR and join this to this and join this to this. Okay, so now from here, the floor plates changes. The, what do we say? For public areas, we only have this much. And I'll just say that finish. And say that don't attach. Okay, and HH, sorry, dot HH, R enter realistic. Okay, so let's go to 3D. Fine. So see, as I said, this would be the beam on which either the 9-inch wall or the internal wall will be resting. So here also we will have a tie beam. So this is how you realize while drafting certain details. So what I will do, I will just say the edit boundary, and right now we are not going to take into consideration so much HL. We are not going to get so much technical because this is about modeling a particular structure, presentation, 3D model with perfect details. Okay, required details actually, more specifically speaking. Okay, so these are the public areas. Now, I will again go to first floor, say that CS, but this time I will select this private areas. And for private areas, everything is same, only this materials is different, wherein this material has been applied to it. This is also an existing material of Revit. Okay, so just say that okay, and yeah, fine. Apply and okay. I was just checking that the recording is on or not. Okay, so from here I will just again select this particular boundary and draft from here to here, and from here to here, from here to this point, and from here to this point. But the lines will overlap, so it will pop up an error. That's fine. Just select this line and delete it. TR, join this to this and join this to this. Okay, and the same way, this bedroom, I will just draft it from here to here and just say that pick 1 and 2. Join this to this, join this to this, and join this to this. Just snap it till this point. Okay, so these are the private areas. Oh, one is left. Okay, and let me just finish and check. Don't attach and go to 3D. Yes. Okay, clear? Perfectly placed. Fine. Let's go to first floor again and then say that CS, but this time this would be the washroom floor plate. Again, the same thickness, but the material applied is this ceramic, mosaic, China mosaic, okay, which has been loaded from here only, appearance library, and see here it is. Here, this is that particular thing which has been replaced, but I have duplicated that and renamed it because I have made the changes within the tiling. Okay, and with that, I'll just say that place from this end to this end, because here there is a beam. Okay, and actually there will be a drop slab here, and the technical details of this you will find in other published videos of mine, which is architecture plus structure and how to create such floor plate with a perfect detail. So I have shown in that videos with all its wrapping layers. Okay, but hearing right now we are just considering and this to be this. Okay, since there's a column over here. Okay, this and this entire from this point to this point. Okay, and this from here to here. Okay, and I common toilet was left. Okay, and here there will be no beam, but there will be one wall. Okay, so here also I guess that I made a mistake. This should be snapped here because anyway there will be an internal wall over here. So that's fine. And just say that finish and don't attach. Okay, let's go to 3D and yeah, fine, perfect. Okay, again come to first floor and again say that CS, but this time one thing I forgot within this. Select this floor plate and just say that edit boundary, and we have a wash also. So I will create that and incorporate that as well. Sorry. Now, what is the floor plate that has been assigned to this? Yeah, public areas too. Fine. So now we have couple of extruding landscapes, which has the hardscape also and the softscape also. So we need to create the floor plate for that. I'll just say that CS, that is create similar. And herein I have this public areas too, which has been assigned this material. This is the material which has been assigned to that, which would act or which will serve as a deck at couple of places. Wherein, for example, this is the entire garden, but I will just divide it on the basis of calling this to be 4 feet roughly, and just snap it here and line from here to here, TR, and join this to this. At the same time, this too will serve as a deck. Okay. What about this? Okay, here we have a beam anyways, so not an issue. Again, we have here. So that's, and we have here and here too. Okay, and that would, I will just say that finish and don't attach. Again, I will just say CS and grass for garden and just say that rectangle created from here to here, created from here to here. Okay, and likewise we have completed with done with the creating the floor plates for this particular first floor, all the different floor plates. Fine. So now we are going to start elevating the walls on this particular floor plate, first floor. So let's begin, which will slightly follow a different modeling process, since you see that this particular entire module is divided into two parts. This is the elevation treatment for the front side, as well this is the elevation treatment for the back side. Okay, so we will divide this modeling of this particular structure into two halves. This will be the first half and this later will be the second half. So first we will deal with this interesting elevation treatment which we will create on the first half. So let's start with that. So I'll just go to first floor, and for here I will just elevate the walls till up to this particular this much portion. Okay, so I will just say that wall. Okay, and now we will select our main wall, which has the material thickness of 9 inch and the material of this wall concrete texture. Okay, apply and okay. So let's go do it step by step. AHL, let me just convert it to hidden line. And herein, first is that I will just draw a wall starting from first floor, and the top constraint would be second for now. And I will just, with this particular location line to finish trace exterior, I will just draw this particular wall from here to here. Yes, and then all the way till this point here, and then this particular thing. Okay, and okay, also I will draw it from this end till even I need to cross check and verify at several stages because it is a very interesting elevation treatment. Yeah, fine. So this will come all the way till this point, and this particular wall all the way till this point. Okay, and let me just check once again. Okay, this wall is still here. Yeah, fine. No issues. And for the internal walls, I will just say that wall, but just select this internal wall, 4.5 with the same constraint. And let me just draw from here to here, from here to this point, and from here to here, and from here to here. Okay. Now herein you see that we have drafted this wall entirely, but I guess that this particular wall will stop at this point, and again it will continue from here because there will be a passageway for a person to go from puja room to dining room, CC, and yeah, fine. Okay, so this is done, and don't worry about this blank spaces. Those are of the beam which are putting up at the level below. See, this is the beam and this is the internal wall. So that's why you see that cavity. Doesn't matter. I will again say that wall, and I should have selected this internal wall and just say that CS, that is create similar, and with same constraint I will draft from here to here and from here to here. Now for this particular internal wall, if you just notice, then we don't have a beam. At some places we do have a beam. For example, here we have, but here we don't have a supporting beam underneath. So what will happen if I just go to floor, and if I just see this particular wall, then this is the floor plate, and the wall is getting elevated 6 inch above the floor plate. See, just try to visualize. I'll just say press H and see. This is the wall plate which is elevating from that particular first floor. So in certain cases, we will have, in order to see the flush connection here. Actually, that is not going to be visible, so that is not important also. But I'm just, let's say the base offset to be minus 6 inches. Okay, and with that, now we will see this walls as well. If you just watch it from bottom. Okay. Anyways, this was actually not important, but I'm just trying to make you explain certain things, certain modeling skills which are situational. Okay. Now, what next? Next is that we will what is, yeah, we have to design this particular portion which is having this particular elevation. So what I will do herein, for this particular part and this part, actually even I need to check and have a reference of, and let me just just hide this wall, and if I select this, then it has, and 1 foot 6 inches, 1 foot 6 inches, that's fine. But this has a top offset of 6 inches. So likewise, this is also will have a top offset of 6 inches, both of this, which I made a mistake over here. Yeah, that's fine. Okay. This will be the wall. Yeah, fine. Okay. So this 1, 2, will have a top offset of 6 inches, which would act as a for the floor, and this particular wall, this column also will have 6 inches top offset. Okay, and then I will just go to first floor, and herein I will just select this particular internal wall, which was supposed to be snapped here as well, CS, and this would again with the base offset of -6 inches because there is no beam at that point here. And this two walls, how much thick are that? 4.5. Yeah, fine. So select this CS 1 to 2 and 1 to 2. But in this case, the top offset will only be, let's say that, 3 foot. Not up till second, but unconnected. Unconnected 3 foot. Okay. So let's go to 3D. And yeah, fine. It would act as a parapet. Fine. And herein we will have a wall which we are going to design it in a slightly different manner. For example, if I just go to, let's see that what is the top constraint for this. Yeah, top constraint is second floor with top offset of 6 inches. Yeah, fine. So I will just come here to first floor and again select this main wall and just snap it from here. Sorry, I was supposed to select this main wall and CS, that is create similar, and first floor but the second floor with the top offset of 6 inches. I will draft it from here to this point. Okay, this wall only will be up till here. And if I go to 3D, oh, actually for this particular beam, there was no need for this two walls. There was no need to elevate it 6 inches because anyways this wall was going to come. And yeah, fine. Or else let's do it. Give it a top offset of 6 inch. Sorry, base offset of 6 inch. Yeah, fine. So that will properly place it. Okay, and that will merge. And herein, I'm just going to first floor and go to modify and join condition. Select this junction and say that disallow join. Okay, and take this part over here and take this particular wall over this point. Okay, the purpose of doing this is that we are going to manipulate this wall in elevation, where I'm just going to say that edit its profile. Okay, and we are going to create something similar. So I would just say that go to left elevation, HL, turn to hidden line. And from here, I will just offset this wall 1 foot, again 1 foot, and offset of 4 feet. Yes, and offset of, let's say that, yeah, okay. So this should be, I will just split and edit profile and HL. Yeah, so see, this is the profile of that particular wall. Wherein this, I guess, oh, yes. So this will go till top, offset, and 4 feet from here, or let's say that roughly 2 feet 9 inches. Join this to this, join this to this, and join this to this. Okay, and join this to this. So this is how we have created this particular profile of this is 4 feet. Okay, and yeah. So with this now, if you will just watch, then this wall will appear like this. CC, R enter. Clear? So that is how we have created that particular wall, wherein I am just going to go to modify, and here is, we are just going to apply a different material to the face of this. What would be that? Uh, where is that particular material? Mm, elevation, I couldn't find it. Let me just go here and finish. R enter and manage and materials. Since we have transferred the materials to project standards, so this particular material should be here only. Let's say that modify and paint. Where is it? Elevation. We don't have any material for elevation. Then which material it is? Yes, if I just go to materials, then here is that uh, exterior cladding. Yeah, fine. So this is that particular custom material which I have downloaded the JPEG image, seamless JPEG texture image from Google, and I assign it. So just go to modify, and if I just apply material, then the exterior cladding, just select that and just apply that, and done. Okay, so that is how we have manipulated this particular wall. Okay, now what is next? Next is that I will just come to this particular first floor, and I will just go to wall, and under that we will have this custom curtain wall. Okay, which if I just go to edit type, then you see that at the fixed distance of 3 feet, I have applied this vertical mullion 1.5 cross 2.5. Okay, and if I just say that the first floor with the base offset of 6 inches and up to unconnected 3 foot, so that will act as a railing. So from here I will just draw this HL and draw from here to here, and again connect this to CS, and or let's say that wall, and connect it from here to this part. Okay, we'll stop here. Yeah, fine. And this particular wall, I guess that wall join and disallow, and this particular wall will come all the way to this point. Okay, and let's go to 3D. Fine. Clear, everybody? Yeah, fine. Okay. What we just need to do, I will just select this, and this is the referencing 1.5. I will just say that 1.5 cross 2.5. This is enough. Apply and OK. So lesser size. And while going to instance parameters for this vertical grid, I'll just change it to 45. And select this and change this to -45. Okay, so this is how I have created this particular thing. And this can continue all the way to this point. Yeah, okay. So first floor, select this and CS, and from here to this particular point. Again, this wall, I guess that wall joint and disallow, and bring this till here and let this wall uh, select this and bring this to this point. Okay, just go to 3D. Okay, fine, perfect. And because of the joint condition, you see that this particular thing, actually the earlier one was, or I guess Yeah, see, this has displaced from its location. This has got smaller. So again, I need to change it and bring it here. Okay. So this is how you play with various different techniques of Revit. And this, I would just say that to 45. Okay. So with this, we have created this much part. Okay. Let's now proceed further. Wherein I'm going to say that we have to elevate this particular part. And this wall is at the top offset of 6 inch. That's fine. But we need to create this entire. So again, come to first floor and let's say that select this particular wall and say that CS. But this time the base constraint or the base offset for this wall would be base offset of let's say 8 for 6 inches and up to second floor with the top offset of 6 inch. Yes, fine. So I will just draft it here, but you'll not be able to visualize this particular thing in this floor plan. And from here till here, okay, and none of the created elements are visible in this particular floor plan. Yeah, that's fine, but it has been created. Okay, from here till this point. So it has been the location line. I'll just select and just flip it. Okay, if you want to pursue this, then you can just go to ceiling plan of first floor. Then you'll be able to visualize it properly that this wall should go in this end. Okay, and then we'll have flush surface. Yeah, that's fine. Perfect. Okay, and likewise, we will have this CS create similar from here to here as well. And 3D, yeah, that's fine. So that completes the geometry. Okay, and now with this, we will come to this part later. First, now let's say that we have to elevate this particular floor furthermore. So let's now jump to this particular floor plate. So what I will do, I will just take this particular floor plan and from first floor, I will just say that take it to second floor with the offset from work plane to be minus 6 inch. Since we need to snap this particular different floor plates to that particular level. So herein, what I will do is that I will select this particular floor plate and say that HC, oh sorry, not HC, IC, that is isolate category. While clicking this eyeglasses, you can do that from here also. So that will isolate all the floor plates. Okay, and then from this, I will just select all of this and just say that copy to clipboard and paste align to selected levels, which are right now at first floor. I'll just snap that to second floor. Okay, so highlighted floor overlaps. Which floor did I? Yeah, so this particular floor was supposed to be unchanged. So I will select this and just by pressing shift key, I will just deselect this particular floor. Again, copy to clipboard and place align to selected levels to second floor, and that's okay. Now, since this floor plates snap to this particular level, the first step is that you need to go to that particular HR and this particular floor plan, this particular AutoCAD plan has been taken up to second floor with the offset of minus 6 inches, but you need to go to ceiling plan of first floor. Okay, and from there, I'll just go to VG, imported categories, turn this to halftone, apply and okay. And CC, okay. I will just snap. I will just say that RP, there is a reference plane. I will create a reference plane over here and say that align, click this particular face and this face. And that is how I have snapped the AutoCAD drawing of that particular floor plate. So with this now, you see that there is a little bit of difference. If I just turn it to realistic, then what do you see that we have copied this particular floor plate from the floor below. But if I just say that HI, and if you just look at this particular floor plan, then there is a difference. When you see that this particular wall has been eliminated at this particular second floor and a room has been created. Okay, just for the purpose of massing. Okay, so that thereby this deck and this garden also shrinks. So what I will do, I will just say that edit boundary, snap this line over here and just say that finish, don't attach, and select this and just say that edit boundary, select this and pick lines. Oh, sorry, pick lines and join this to this and just to this. Also join this to this. Okay, and just say that finish and don't attach. Okay, fine. Rest, I guess that there is change in the later part, but that we will do when we come to the modeling part of this particular second half. So let's first now deal with this. So here now what needs to be done is that let's go to 3D and we need to elevate this particular this walls here on this particular floor. So all the walls which have been created 1, 2, and 3 and 4. Sorry, this wall I guess that needs to be joined. Join 1 and 2. The internal wall need to be joined. So join and yeah, fine. Okay, so actually it should be other way around because this walls are going to elevate on that particular floor also. So sorry, my mistake. Uh, Let me just click undo and unjoin it, and let's say that join and join again, but I will just say that switch order and select this and switch order with this, select this and switch order with this. Okay, and with this now I will go to first floor, and from here I will just select this particular couple of walls, CC, that is consistent colors, so I will be able to see, and I'll just hide this particular HC height category, so I will be able to visualize the walls and all this particular walls which are needed for that floor above. I will just select all of these walls, and for them I would just say that the top constraint, base constraint varies, that's fine, but the top constraint to itself is the third floor. Fine. So just with one click, all the walls have been elevated up till that particular designated floor. And here you see the cavity. So that's because that for the floor below, we had here the beam which was snapped, okay, which was snapped at the lower level. This particular beam has been created at ground floor with the top offset of 8 feet 6 inches. But here that doesn't exist. So that's why we have this vacant space. So what we need to do, we need to fill this spaces. So one way is that you can snap a beam over here, or what you can do is that just say that edit boundary. And for this particular floor plate, that is this second floor, I will just come here and draw the lines and complete the shape. Okay, and just say that join, split all this and just join the shapes. So TR and TR, and let me just go to 3D and just say that finish. Okay, clear? But here too, still, since there is no beam over here at this particular, at this level, if I just take you to the first floor plan, and you see that HR, no, sorry, ceiling plan of first floor, then, sorry, actually, even I got confused. Yeah, here there should be beams. And if there are no beams at this particular level, then you need to edit boundary and go to second floor and have a flush surface. Okay, because we are right now focusing on the modeling part and structure is not considered. For this lower level, I just drew to make you understand that this will be the beam network. Okay, But that beam network, we are not continuing on the floors above, and we are just focusing on the modeling part. Okay. Now here at this particular designated floor, that is on second floor, we have a wall over here also, wireframe. Uh, where is the AutoCAD drawing? HR. Yeah, we in order to draw that compute that particular floor plates, we give it a base of offset from work plate to be minus 6 inches. Okay, so here also I need to say that edit boundary and complete this and just say that finish and don't attach. Okay, and actually on this particular floor, this wall will not come. This particular wall will not come. So what we need to do, this can be done in a couple of ways, but right now, just to save time, I will just go to this particular second floor, and herein I will create a cavity within this particular wall. Architecture, and you see that you can create a cut in the opening. Click this wall 2 times and just create this particular thing and just cut. Okay, which would have base offset to be 10 foot. On which particular floor? Second floor. Yeah, fine. So top offset to be minus 10 foot. Base constraint. Yeah, but base constraint to be first floor. Instead that, I will just change this to base constraint to be second floor and top constraint to be third floor, because we want that cut only here on second floor. Base constraint to be second floor with the base offset of 0, and top constraint to be third floor with the top offset of minus 18 inches, which will be left for beam depth. Okay, and now if I just go to 3D, and you see that we have created a cut within that particular wall. Okay, it's perfect. Fine, no issues. Now I will just go to this particular second floor, see, and I will just say that basic wall, but this time, let me just check. It's just a different wall, no, it is the same wall, the material has been different. Okay, so I will just select this particular wall and CS and create it from second floor, but with the base offset of. There can be a beam, there can be a tie beam, and right now, if not that, we are just considering an ideal situation, minus 6 inches to match the surface of the floors. Okay, so second floor and up to third floor, and just create one and select this and CS. Select this internal and CS, and with the same constraint, draw from here to here. Okay, and go to 3D. Fine, so that is how we have done with the massing part. Okay, now just to differentiate this, I just go to modify and apply this material, brick cladding, on this surface and on this surface. Okay, rest we will look this particular thing and then we'll match, but right now let's just proceed on further with this particular thing. And what else to be done over here? We have created this particular box and this wall. Okay, this wall will stop here itself. And this is a little bit computed. This particular elevation facade treatment has been computed in such a way that I need to refer it multiple times. So just pardon me for that. This is a continuous railing, and yeah, fine. So this wall, in this case here, it will be, let's say that this will stop here, but if I just make it stop, then this will go inside from there also. There are multiple ways of doing this particular thing. For example, you can just say that this wall is only constrained up till this particular floor, and then you can draw another wall here. And if you want to manipulate this wall also, that can be done in a couple of ways. I'll just say that edit profile and just say that HL, and I will just draw a line from this surface, join it with this. TR, join this to this and join this to this, and just yes. Okay, so that is how we have eliminated that particular wall But what we just need to do is that extend this particular thing, edit boundary, and snap it to the surface and don't attach. Okay. Okay. Clear. Done. Now let's take this particular two walls, the parapet walls, and just select that. Also, this two curtain walls, that is 1 and 2. All of these 4 elements I have selected. I'll just say that copy to clipboard, which are right now putting up at first floor. I'll say that paste align to selected double up to second floor. Clear? So that have all of them has been snapped to that particular level. This, I guess that unconnected should be 3 foot 6 inches. 3 foot 6 inches. Yeah. And likewise this as well. 3 foot 6 inches. Okay. Clear. And this particular thing at second floor, I will just extend it to this particular part. 3D. Yeah, fine. But again here we have this Lowrise, this curtain wall only. So we will have to edit this particular wall for that. But we will do that later once we elevate this particular floor. Fine. So this much is done. Okay. Further, now let's continue elevating the third floor. So this particular floor plan, I will just take to third floor. Okay. And I will just say that isolate category. I will select this particular, all this floor plates, and deselect this by pressing shift key. I will say that copy to clipboard. And I'll say that paste align to selected levels. I will snap it to third floor. Okay, so all the floor plates has been copied, HR, and also I will just take this AutoCAD plan is already at third floor. Yeah, fine. So what I need to do, I need to go to ceiling plan of this particular second floor in order to VG imported categories, turn it to halftone, apply and OK. Fine. And from here, I will just say that align this face to this face. So with this now, what you see that the floor plates of this are entirely following some different profile. Okay, talking about the front part, where you see that you have a wall over here, the garden, you have a wall. This wall has continued till here. So what we will do, I will just say that edit boundary and snap this to here. Okay, and just say that finish, don't attach. Edit boundary, this to here, don't attach. Edit boundary, this to this particular part. And I guess that this is eliminated for that last floor, or it does exist. Yeah, you see, this is a continuous floor. Okay, so I will just get rid of this 2 lines and TR and join this to this and just finish. I don't attach. Okay, and likewise this is fine. But herein I will just say that edit boundary and snap this, because this wall will continue in this at this particular floor, still this part, creating a box treatment, elevation treatment. And yes, rest I guess that everything is proper. Let's furthermore continue with the modeling part of this particular level, wherein you see that couple of walls will continue on this floor plate as well, but couple of walls will not. So we will just see that what. For I'll just temporarily hide this particular floor, and from here in I will just select this 1 and 1, 2 and 3, 4, 5 and 6, and all the 6 walls I will say that take it up to
terrace plan. Fine, but this wall will only be built up to this particular portion. So we will have to go to, let me just close this unnecessary views, and I will just say that go to third floor, that we cannot see the AutoCAD plan. In order to see the AutoCAD plan, we need to select this AutoCAD plan and change this offset from work plane to 0, because we don't anyways need to manipulate that floor plan in reflected ceiling plan of second floor. So turn it to half tone, and then just say that select this particular wall CC. So see, this is the floor plate, and yeah, okay, and just say that CS, let's create similar third floor to terrace floor, and just build that particular wall from here to here, and complete. Okay, done. Now this particular wall, as per the elevation treatment, is getting inserted inside, and if I'm not wrong, then this particular edit boundary, and this will stop here. Okay, and just say that finish, keeping closed loop. So yeah, just get rid of this line and say that finish and don't attach. Okay, so this particular wall now will start from here. So I'll just say that CS, that's create similar, and just draw that particular complete wall from this point to this point. Okay, let's go to 3D. But here it will have a base offset of minus 16 inches, because here there will be a beam. Not necessary, it can be only here also. As per the structural consideration, there might not be any beam over here, but I'm just considering an ideal situation. So I will just say that minus 18 inches. That will insert that wall 18 inches down. Fine. And create that same, and just say that CS, and on this edge as well. But here the constraint will be the top unconnected height to be only 6 inches. Oh, sorry, 2 feet. 18 inches of this and 6 inches, so that will be 2 feet. Okay, and let's just see. Yeah, fine, perfect, absolutely perfect. Okay, and this particular wall here, this particular wall will extend. Okay, here at this edge from here. So what I need to do, so in that case, actually this particular deck and garden both will extend. Let me just check in that particular project, because even I don't, yeah, see, so it is extending to this particular part. Okay, fine. So I will just come here and get rid of this particular edit boundary, and just get rid of this because we don't need it, and so say that don't attach. And this I will just say that edit boundary and extend till here, don't attach, and this edit boundary extend till here and say that don't attach. Okay, fine, and just say that CS, that is create similar, and with this same constraint, that is minus 18 inches and up till terrace level, I will just elevate this particular wall from here to here. Okay, and join this with this wall. Okay, don't worry about this particular thing. We can just say that edit boundary, and we can lay a floor plate over here, which would act as a grass. So from here and here, the walls which will be there will have punctures and windows which will have access to this particular garden area. Okay, now from this part we need to eliminate. So just say that CC, create similar, and just go to modify and join, and from this floor plate, this wall and this wall and this wall. Okay, just join it and just eliminate the extras, HR, and just say that R enter. Okay, so much has been built. Now I will again go to this third floor and just select this wall and CS, create similar, draw from here to here. What is the problem? Yeah, so draw from here to here, highlighted walls overlap. Okay, so in this case we need to get rid of this particular base offset because there is a wall on the floor below. Okay, And this particular wall, this is the special wall, wherein you see that for this floor, it is coming up to this particular edge. Okay, this particular edge, and I guess that we need to join this to this. Yeah, so this particular floor for this particular wall for this particular floor is coming up till this, but here we edited the boundary. Here we edited the boundary and get rid of this particular part. But on this particular floor, again, this wall will come till this point, extrude till this point. Okay, so what we need to do, we just need to say that this to be terrace plan, and herein I will just edit its profile again in order to match this. So this particular part, I will just go to third floor and extend till here, but we cannot do it here. We need to come here to left elevation of 3D, but I'm not sure that whether I'll be able to. Yeah, fine, no issues. Okay, so I will just say that line and just extend till this, because this is the extruding floor plate for that particular level, and just join to this. And now if you just visualize this, try to visualize this wall, then you see this is the profile of the wall. Okay, and just say that finish. Fine, absolutely perfect. See, so this is our enter. Yeah, so this is the box that is extruding out even further more than this. See, I'll just show you. Okay, so see, this is the edge, and from here it is extruding 2 feet more. Fine, so just for the sake of elevation treatment. And this particular wall will also have its profile edited, wherein if I just click this, then you see that this HL, and because of the graphics display option, you're not able to visualize this, and I will just say that show ambient shadows, apply, and okay, and also I will turn off the shadows temporary. So you see, this is the profile of that particular wall. Clear? And just say that fine. Yes, okay. R enter. And yes, okay. So we are going to do that particular same changes onto our project on which we are working right now, wherein I will just select this particular wall and first take this up to terrace plan. Okay, and here I will just select this wall and just say that CS, and just go to ground floor and create that same wall up till here. And this, I guess, needs to be extruded still 9 inches. Okay, still 9 inches it needs to be edited. So just snap it here, or let's go to left elevation and up till this edge. Yeah, fine, sorry, because that beam was not there, so I just forgot to incorporate that as well, that 9 inch of beam. Okay, and that's fine. R enter. Yeah, okay. And this particular HH height, and both of this walls, and even this wall, all of that, I will just say that the top constraint to be terrace plan. And perfect. Oh, sorry, not terrace plan, but sorry, not slab top, terrace plan. Yes, fine. And with that, now what I need to do, this has also taken up to slab top, I'll just take it up to terrace plan. Fine. Okay, and now we need to edit the profile of this wall. So I'll just say that edit profile, HL, and I'll just draw a line, LI, from this point. Am I able to find the snap point? And if not, then just go to this particular elevation, and you are able to have the references 1 to 2. Just join this to this, TR, and just close. And also we need to get rid of this much part as well. So again, I'll just say that Li, and this is the level. So draw from here to here and here to here and join this to this and get rid of this line. Okay, so that, sorry, join this to this and join this to this, and that makes the profile of the wall really interesting in order to match the elevation. Okay, clear? Fine, and just say that finished. Okay, perfect. Now we can lay a curtain wall over here. Actually, here I was supposed to elevate it till this here. Okay, so see, drafting with Revit is very easy because the snap points are automatically created. And with this, I will just go to, let's say that second floor, and here I will just create this and CS, and I will just say that second floor 6 inches and top to be terrace plan, or sorry, not terrace plan, third floor, and have we, yes, the beam is there. So I will just say that top offset of minus 18 inches. And from here to here, I will draw this curtain wall and just go to 3D. See? Okay, perfect. And as far as the curtain wall is concerned, I guess that the spacing is too much. I'll just change it to 6 inches. Apply. And okay. Yeah, fine. So that looks, I guess that, let's look. Okay, that is, that depends on you, that how you want to make it appear, or else I'll just go to edit type and I can even try this 4.5 and just say that apply. Actually, this mullions, I guess that are of the greater size. I need to select this smaller size, not for box wall, but this. Yes, okay. So see, yeah. So with that, now, if I just change it to 6 inches, or let's say to 3 inches, that would look appropriate, because the mullion size was not proper, so that's why I guess that, yeah, fine, perfect. Okay, so this is how are actually sorry, but this is actually not important, so that depends from preference to preference, but I'm just trying to make it visually look proper. Yeah, so it's fine. Okay, I'm happy with this. Okay, and likewise you have to create that over here as well. So I'll just go to third floor and just say that wall, and I will select that custom curtain wall. That's fine. Base offset to 6 inch and unconnected to, let's say that 3 foot. Draw from here to here and also draw from here to here, of which the play would be, I would select this, go to the instance parameters and change this angle to 45 and this to -45. Okay, clear. Okay, so with this now, what remains is this part, wherein you see that here there is an empty space which we need to fill with either putting a slab or something else. So what would be that something else? So in order to see that, what else, we need to go to that particular project, complete project, and check the elevation treatment. Yeah. So here is this particular space is bounded with the help of other wall, main wall 9 each other, which has a special construction wherein that wall actually is acting as a slab. So see, wall concrete texture 2 feet. The thickness of that particular wall is 2 feet. Okay. So see, this is the regular main inch 9 wall, but these 2 walls, this one and this other, this and this inside, this 2 and this 3 walls are different types of wall which have a thickness of 2 feet. Okay, in order to have this particular elevation treatment. So I will just come here and I will come to third floor because that wall is on third floor, and I will just say that WA and that main 9-inch wall other which has the thickness of 2 feet with that same concrete wall concrete texture appear over here. So if this is a wall, then I need to change its constraint to its own thickness is what is the thickness? Yeah, so its thickness is 2 feet, but we need to decide that up to what part we want to make it model it. So I would just say that 9 feet 3 inches and top should be terrace level. So that would make its thickness exactly, I'll just change this offset to 0, and unconnected height is equal to 9 inch. Okay, so I would just say that yes, so I would just say that from here from this particular point I'll just flip, but we cannot visualize this in third floor, so I forgot to change this to second floor, I guess. Yeah, so second floor, and with that not terrace level but third floor. Sorry, one mistake, because if you just check this, then this particular level is level 2, that is second floor. So while in, let me just check that whether in this particular floor plan can I visualize that wall, the construction of that wall. No, I cannot. So what I need to do, I need to go to, again I will select this particular AutoCAD plan and just say that offset from work plane to be -6 inches. Okay, and go to the ceiling plan of second level. Ceiling plan of second level. Fine, and now I just go to VG, imported categories, turn this to half tone, apply, and okay. The AutoCAD drawing is turned to half tone, but now I'll just say that wall and that particular other wall with this second floor 9 foot 3 inches and top constraint to 3 inches, which makes its unconnected height only 9 inches. I will try to draft, and yeah, fine, see, so now you can visualize, and I will just say that this particular thing to finish with exterior, and from here to here, see, exactly, it is absolutely perfect. And now if I just go to 3D, then you see that we have filled that particular space, but essentially with a wall. Okay, and now we need to, I guess that this particular floor plate I was supposed to, where is it putting up right now? On second floor. So copy to clipboard, and actually all the floor plates, this was, yeah, this is the third floor, so I forgot this. Yes, this I forgot. So I just say that copy to clipboard and paste align to selected levels to third floor as well. Yes, okay, fine. So for this particular elevation treatment, what I need to do, I need to go to take this particular to first floor, and while going on first floor I'll just say that 0 and go to the first floor, and with that, now if I come here, then you see that, just try to visualize this particular thing. I don't want to shift the AutoCAD plan right now, just in order to make this particular elevation treatment, but just try to visualize that this is one wall, this is one wall, and this is the base. This is the base. So here for this particular base, again we will use that same wall. So WA and that 9-inch wall others. Okay, but this time the base constraint would be first floor, and I'll give it a base offset of 15 inches, or let's say 9 inches, because the thickness of that is okay, let's keep it 15 inches only. Yeah, fine. And unconnected 15 plus 9, how much it would be? 15 plus 9, or we can manipulate this. That's our own choice, that how much you want the elevation treatment to be. It could be 9 plus 9 is equal to 18 inch also. So let's do that. Okay, I will just create that particular wall from here to here, this part. Okay, now I will just say that WA and that same wall, but the constraint I will change that from first floor up to terrace plan, not terrace plan. Yeah, terrace plan. Let's just, or actually third floor. Yeah, fine. Two story it will be. Okay, and from here I will just draft that wall, not this wall, but now the regular main wall, in order to have that elevation treatment. And now let's just check in 3D what is the flaw, and if there any, then let's eliminate that flaw. Okay, it's absolutely perfect and we don't have any issues. And this consideration, 9 inch plus 9 and 9, 18 inch, that makes this, well, that is too much. I guess that only 9 inch should be the thickness. So yeah, the base offset is 9 inch, and 9 plus 9, 18 inches. What's the problem? Okay, yeah, sorry. Yeah, 9 inch and unconnected height, its own thickness should also be 9 inch. And with this, I will just say that copy to clipboard, paste align to selected levels, and to third floor. Okay, but we slightly need to change its constraints, wherein this particular wall is putting up at third floor. So third floor, I would just say that minus 9 inch and unconnected height to 9 inch. Yeah, fine. See. So with that, now we have concluded with this elevation treatment. Okay. The only play for this two walls and this one wall is that if we just check this, and you see here we have this. At the same time, for this wall also we have this small sliver which we need to create. So let's just quickly do that. So here this same pattern, the same thing will continue here as well. So I'll just go to edit profile and go to left elevation, so we can have the reference and snap points HL. Yeah, fine. And from here I will just, and see, again I need to refer once, sorry guys. This, and okay, so LI, and roughly I will just come here, and this should be 1 feet because this is also 1 feet. And some design concepts, LI, lot of noise, unnecessary noise, and just move this 4 feet high. LI, sorry, again not LI, just join this to this and join this to this. Okay, and join this to this. So this would be the profile of that particular wall. Okay, in order to match this. And how much is this? Yeah, 2 feet 9 inches. So this should be 2 feet and 9 inches will be for the wall above, which is putting up here 3D, and here there will be a parapet wall. So let's just check. Yeah, fine. So this would be a 3-foot parapet wall. So this should only be 2 feet. Yeah, okay. So I will again come here to left elevation in 3D only, and essentially I would make this 3 foot, not 3 foot, but just 2 feet. So with the 3 foot of parapet, this would make its 5 feet. Okay, and that would look proportionate. Fine. So this is done. I'll just say that finish. But somehow it is not matching with this surface, I guess. And we need to extend it till this edge. Yeah, fine. Okay, complete. And also this, I will just say that copy to clipboard, align selected levels and up to terrace plan, and just say that okay. Fine, just get rid of this particular 6 inch offset from now. Yes, and just close it and have a closed shape. Also, this beam will come here. So just say that copy to clipboard and align to selected levels and to terrace plan, but get rid of this 6-inch top offset or connected height to 18 inches. Yeah, fine. R enter and yeah, see. Clear? So this is how to manipulate. And as I say that join this to this, this to this. Okay. This should be joined. Yes. So one uniform surface. Okay. And herein, I will just say that edit profile and HL and just go to this particular front elevation. And herein, I will just create a small sliver of something like this up till this level, and just get rid of this split lines, join this to this, join this to this, and how much it would be, kitna hai? Let's keep it 3 inches only. Yes. Okay, just a small sliver. And see, we are modeling the entire stuff in 3D itself. Say that and join. What is the issue? I created the wrong cut. Actually, I will just say that undo a couple of times. And this wall should extend till here, then why it is not? Let's select this entire stuff and just move it up to this edge. Okay, fine. And select this and just move it till here. And TR and join this to this and join this to this. Okay, and now hopefully it should. Okay, here also we need to join this and yes, and unjoin. Okay, and R enter. So this lever is too huge. Let's just check here. And this is just a small sliver, I guess. But it is from the surface of this wall. Yeah, fine. This wall is entirely from the surface of this wall. So in our case also it is the same. Yeah. So what is the problem? I'll just click undo a couple of times. Let me just say that extend this somewhere here in the center. And let's not have a join face. Yes, okay. And with that, now let's check. Okay, fine. So modeling was the error. Yeah. Snapping of lines, not modeling. Yeah. Snapping of lines was the error. So when you're working with Revit, you need to be sure of a couple of things. A lot of things. Okay. With that, now you see that this perfectly appears and you have the small sliver with accident. Okay. See through. Fine. So with that, now we are completely done with this much part of creating the elevation. So you see that there's a box here, and let me get rid of this particular. Why is this floor plate? Okay. Yeah, we copied the floor plate, but we forgot to edit the boundary. So I'll just say that edit the boundary and get rid of this, delete, and just say that finish and don't attach. Okay. So done. We are done with this part, this entire part, front part, and now we need to check this particular rear part.
For which first we will take this particular AutoCAD plan and we will snap it to first floor, and let's check the footprints and the change in the footprints at consecutive all floors before snapping the walls. So I'll just go to the particular first floor, and herein I would just say that this particular align, and I'll just align this face to this face. Okay, so here I guess that everything is proper, so we don't need to make any changes for the floor plate of this. But for this particular second floor, I guess that I will again select this and snap it to second floor and go to the floor plan of second floor, wherein VG imported categories, turn it to half tone, apply and OK, and just snap this particular plan over here. So you will realize that there is a change in the footprint of the floor plate. So I'll just say that edit boundary and edit this, saying that this don't attach, and this I will just say that public area and get rid of this and just finish and don't attach. And this master bedroom, we will just extend the boundary till here. Okay, so this was the change in the floor plate for this particular level. And rest again, the same floor plate continues on the third floor. So that remains the same. Okay, so now with this, we can start laying the wall. So again, I will just say that align, come here, snap it, and send this to first floor and go to first floor. Okay, and just start snapping of the wall, wherein let's see that what we need to do. Okay, so this is going to be the externals. So let me just select all the three this and just copy to clipboard, place align to selected levels to first and second and third, and just say that okay. Yeah, so here it will not come. I'm not supposed to select third floor. Okay, and likewise now for this particular, I will just say that I would give it a offset of top offset of 6 inch, which would act as the body on which the railing will rest. And likewise, this too also will have 6 inch offset. Okay, but herein, till this part only we need that offset. So what we will do, we will select this particular wall and just say that CS, go to first floor and just say that base offset to 0, or let's say that base offset to minus 18 inches. But the beam already exists, so just say that 0 and unconnected to 6 inch. We need to just create the per beam on which the railing will rest. Okay, fine, and let's go to 3D. Okay, this is done. Likewise, all of this I was supposed to say that all of this as well should have a top offset of 6 inch. Okay, fine. Okay, so now let's start modeling the walls of this particular floor plate. So I will just go to first floor and just say that walls, but now I'll just change this unconnected to second floor with the top offset to 0 and wall 9 inch. So we will start constructing the wall 1, and let's say that all the way till this point, and then just convert this to say that internal, because this is going to be the internal wall, which will be all the way till this point. And also we have an internal wall over here. Okay, and internal wall over here as well. Okay, and over here as well. Done. Fine. And again, select this wall, CS, and construct this main 9 inch wall. Snap it till this point. Construct this entire wall. Actually, not entire, but only up till this point. And actually here, I'm not sure that whether there is, let me check. Okay, yeah, fine. Here there is a 9 inch wall. So wall, and just snap it till this point and start from here, continuing till this particular point and all the way till here and complete the geometry. Okay, wall again, this wall 1 to 2 and 1 to 2, and also here to here. Okay, but herein I will just say that TR and join this to this. Okay, so what would be the change in the floor plate for this? So I will just select this particular thing, edit boundary, and delete this, and just say that join this to this, and join this to this. Okay, and finish, and say that don't attach. Okay, and likewise here too, for the public areas, I will just get rid of this and just split TR and join this to this and join this to this, and just say that finish and don't attach. Okay, so we will not see the surface of the beam here. Also, we have a internal wall. Just select this, press tab until we select that particular internal wall. Uh-oh. And just say that CS and just create one over here as well. Okay, don't worry about this vacant spaces because that pertains to the beams on the level below. Okay, so likewise, just edit boundary and join this as well, and join this as well, and just say that split 1, 2, 3, 4. Join this to this. Okay, and join this to this. Fine. Okay, with this many changes, I'll just say that finish and don't attach. And let's go to 3D in order to check. And we did that particular changes on the first floor, right? So I will just say that HH and HH. And yes, so see here, I will just come here and select this and just say that HH. So we can visualize this floor plate. Okay. And I will just say that join, get rid of this overlapping volumes. Likewise, I will say that join, select this and get rid of this. Okay. And all of this beam surfaces. Okay. For the floor to continue. And yes, everything is perfect as far as this particular floor plate is concerned. I'll just say that HR. Okay. Now, herein, yes, one more was left. Join this to this. Okay. Now we will come to second floor, and we need to decide that which wall would continue and which wouldn't. So I would just say that hide category HC, hide it for temporary. And herein I need to select this 1, 2, 3, 4, 5, 6, 7, 8, 9, and all this particular wall, which are going to continue and have the same footprints on the floor above. So only this wall will change. So this will have the unconnected up to terrace, third floor, sorry. Okay, and just say that HR. And I guess that this particular wall was this particular wall was not supposed to be taken, because here at this particular level, that is second floor, this wall will not come. So I will just say that snap this wall only up to second floor. That's fine. And just come to first floor, and herein I would just say that first I will just align 1, 2, 2, and then take this particular plan to second floor. So with that, we'll be able to visualize that what wall will come here. So now I will draw the required wall over here. So that particular 9-inch main wall, second floor to third floor, I'll connect from here to here. And this wall will be the internal wall. So I will just change it to internal wall and just snap it. No, it is not an internal wall. What is the thickness of this wall? 6-inch. How is that possible? Fine. Let's just continue this same wall only. I might have made mistake in the AutoCAD drawing, so not an issue. Okay. And here also this wall. Let me just say that take all this wall till this particular part. Okay. and CS and continue this wall till here and join this wall to this. Okay, fine. And let's go to 3D. Okay, fine. So now you see that this much portion is acting as an elevation treatment and it is projecting out. Okay, for which I guess that this particular 1 and 2, this wall should have negative 18 inches. Okay, and here there will be a door, and at this portion is this wall. Let me just check the AutoCAD plan. Oh, here there is no wall. Sorry, here there is no wall. So for this particular second floor, sorry, first floor, here there is no wall. So this wall will stop here at first floor. And let's check in 3D. Fine. But that wall was actually continued. So, okay. So it doesn't matter. We will just go to this particular floor plate. And herein, I will just draw CS with this constraint and a wall here as well. A different wall. Okay. That makes it perfect. Okay. Absolutely fine. No issues. Okay. Clear? Okay. And from this particular floor plate, I will just say that join and get rid of this particular wall. And this particular second floor, I forgot what. No, it's done. Then which level is this? Yeah, this is the third level. Okay, we made the required changes on the second level, but this is the third level. And also this particular here, there will be a beam which will continue. So again, you need to go to second floor and just say that wall, which would have base offset of -6 inches and not unconnected up only up to 6 inch, or let's say 2 feet, and construct a wall from here to here and here to here. Okay, and just go to 3D. Yeah, fine, absolutely perfect. So in that case, this wall will also have a base offset of -18 inches, which would act as a beam. And wow, okay, perfect. Fine. So now we don't have any issues and it's complete. Wherein this project is this particular part is projecting out. Okay, fine. So now let's complete this, taking this particular all the required walls on the floor plate above. So now I will just go to this particular second floor and snap this to this and just say that this AutoCAD plan I will take to third floor. Okay, and I just close this second floor, first floor, and now I'll just go to third floor. Okay. So now herein, you see that this is exactly same like this particular floor plate. So what can we do? We can just say that, yeah, the floor plates, we don't need to make any changes regarding the floor plate. The floor plates were only changing its profile at second floor, but at third floor, it's exactly same as the first floor. But walls, we need to build the walls. So which wall will be common? So we will just go to this particular 3D here, and let's say that this will be the common wall. This will be as well, and this entire thing. Or let's hide this particular floor category, HC hide category, so we can just visualize properly. Okay, and so this particular wall, this wall, this and this, all these walls will continue the way it is supposed to be. This one wall, yeah, this will also continue. And herein, this we will not have this particular wall at this particular floor. Okay, so this wall I will just deselect and we will draw one more wall over here. Okay, this particular wall will, and likewise here also this and this will we will have to draw, and this and this and this. Okay, so this much wall will continue to top constraint, let's say that terrace plan. Okay, and now let's say that HR and go to that particular third floor and draw the required walls, okay, which were discontinued at first floor, but and second, discontinued at second floor, but do exist on third floor. For example, this particular one wall and the couple of remaining walls. Okay, so I'll just go to third floor, and here I would just say that select this wall and just say that CS, and I will change this constraint directly from third floor to terrace plan. Okay, third floor, and snap it from here to this point where it will be full wall, and also from here to here. Actually, let's no, we cannot take this particular wall because at second floor it doesn't continue, so we'll have to draft a new wall. So I will just select this wall only, whose constraint is from third floor to terrace plan, and just draw it and complete. Okay, fine. Likewise, I will just say that I guess that here also we need to make these changes, wherein I just get rid of this TR within the floor plate. We need to make the changes TR and join this to this and finish. Don't attach, and also this edit boundary. Let's get rid of all this LI and draw this to this TR join this. Sorry, split TR join this to this and join this to this and join this to this. Okay, and just say that finish and don't attach. Also, we don't have the structural consideration, so we can just do this for the internal walls also. I mean, this floor plate where this internal wall that's snap and edit boundary, and same for this because we don't have a beam below. We did that for first floor because we had a beam below, but for all the rest of the floors, we will just snap it to the existing line. Okay, and also this edit boundary and get rid of this. I guess that these changes were required at second floor also, but we forgot. Doesn't matter. Once we'll complete this, I will just switch this, take this particular AutoCAD drawing to second floor, and we'll do the required changes within the floor plate there also. Okay, now I will just select this particular floor plate and just say that CS, but this time I will just say that negative 18 inches, and the top should be unconnected 2 feet. That will leave the 6 inch of body on which the railing will be placed. Highlighted walls overlap. 3D. Which walls? Okay. See, so this wall is up till here. So it doesn't matter. Let it overlap. We will join it. 1 and 2. And 3. And this goes 3D. Okay. So herein, I guess that it's here only one wall was there. Then why did it say that overlap? Yeah, fine. Here it was. So I guess this was only supposed to be drawn till this point because we have the elevation treatment here. Okay. Okay, fine. And also join and get rid of this wall from that particular floor plate. And again, now this particular wall on this particular floor plate will be eliminated. Okay, this will be eliminated. And on third floor, we will again have this wall. Oh no, actually this wall, third floor, it will come or not. No, it will come, sorry. This will act as a deck. Yeah, fine. So this wall will come. Only thing is that I will just delete this and draw a wall which would not have the base offset but only have unconnected of 6 inch, which would act as a body, and 1 to 2 and CS and 1 to 2. Okay, and let's go to third floor. Yeah, fine. So that make it perfect. Okay, so now we are perfectly done with the modeling part of this as well, except for railing, but that's not an issue. We will place the railing once we are done with the modeling part. So there's anything left here? Nothing except for this floor plate. So why this floor plate was missed over at here? Also, yes, one step I was missing was that, yeah. So here, edit boundary, and we don't have any beams below for the second floor also. So just get rid of all this and just snap it to the perfect place it is supposed to be, and just say that don't attach and edit boundary and just finish. Don't attach and just edit boundary, delete line from here to here and split. Join this to this and this to this and this to this, and just snap this over here and just say that finish and don't attach. But here we also this I need to get rid of. Yes, don't attach. And here, since I eliminated that particular floor plate of terrace, I mean the deck, it has discontinued from all these three portions also, which we need to build. So I will just say that edit boundary and delete this tr and join this to this and just say that FA, that is floor, and just say that public areas 2. And for that, I will just define a floor plate on this missing section, which we deleted by mistake in manipulating the floor plate for this particular level. And yes, and just say that finish and don't attach. Okay, so with this now we are completely done. Perfect. And we don't have any issues. Fine. So now, without wasting the time, let me just select this and just snap this to terrace plan, since we are going to now construct the terrace floor plan. Okay. But before that, the places where the beam will come, the beams. So I just need to check. Yes, here. Why is the, let me just go to terrace plan. VG, imported categories, turn it to half tone, apply and okay. Yeah, okay. That is the elevation which is being seen. So, okay. So what I need to do, just say that snap this to this. Okay. And now just draw the required parapet wall, which will be persisting on this particular floor plate. But before that, I will just select this and just say that give it a negative offset of 6 inch and just go to the ceiling plan of third floor and VG and imported categories, turn it to half tone, apply and okay. And draw the required beam network here. See, this place here and okay. This 1, 2, and 3 places we will need beams. So I'll just say that CS and base offset to be 8 foot 6 inches up to terrace level. And just say that 1 to 2 and 1 to 2 and 1 to 1 to 2 here as well. Okay, and here as well. Fine, and you go to 3D. Fine. So that completes, that does the job perfectly. And now going to third floor, I'll just say that shift this to terrace floor, close this terrace floor reflected ceiling plan, and go to terrace level floor plan. And herein, I will just say that FA and where is balcony pathway deck terrace, edit type and edit. And this is the material which has been applied to it. Okay, which we will just draft. So just pick line 1, 2, 3, 4, and 5, 6, 7, 8, 9. And likewise, just stay tuned and I will just quickly complete with the drafting of this particular. Okay, and this will go inside. Yes, and with that, I'll just say that TR join this to this, and rest no other places we need to join, and lines cannot intersect here. So just say that finish and don't attach. Go to 3D. Yes. Okay. The floor plate has been laid. Just say that join, and with multiple join checked on 1, 2, 3, 4, 5, and just get rid of the overlapping volumes. And that wouldn't take much time. Okay, CC and R enter. I guess that I missed the beam over here. So I need to go to ceiling plan of third floor and just select this main wall 9-inch, terrace plan and unconnected. If it is the third floor and the base constraint is terrace plan -1/6 and unconnected to 0, or that cannot be 0. So how did I do this boom? What was the constraint for this? 8 foot 6 inches up to terrace level. Yeah, fine. So wall and 8 foot 6 inches up to terrace level. And yes, just draw this one beam. And yeah, that's fine. See, perfect. Okay, we don't have any issues. Okay. Fine. So now let's wall, and this would be on terrace plan with base offset to 0 and unconnected to 3 foot. That would act as the parapet, and I would just quickly constrain and model this and draw this particular wall following the periphery, following the AutoCAD floor plan, and just draw the parapet wall wherever required, following the footprints. And yes, it's done. Okay, 3D. So with that, now we are completely done with the basic modeling part of this particular structure, wherein you see the elevation treatments projecting out. Now we need to apply the material, at the same time differentiate the different in and outs for the floor plate we did for the elevation treatment, at the same time put the openings. Okay, we will do that just in a while, but before that I will just say that this laptop to 15 inches, and herein I will just go to the slab top, but we cannot see anything. No, not reflected ceiling of slab top, floor plan of slab top. Yeah, fine. Okay, and FA, and that same balcony terrace, and I will just say that draw it from here to here and just say that finish and don't attach 3D. Okay, and just say that join 1, 2, 3, and 4, and CC or enter. Okay, clear. Okay, so now let me just say that AutoCAD drawing and just hide in view by elements. And let's permanently hide that AutoCAD drawing in order to visualize this particular structure. So let's complete with the modeling part of this particular low-rise residential building by adding the missing elements. For example, if I just select this, then this would be all of this, the top constraint for all of this, which would act as a parapet wall for wash, will room bounding 1 and 2, 1 and 2, 1 and 2, and I will say that top of set to 3 foot 6 inches. Okay, so that would act as a parapet wall. That's fine. Okay, and if 18 inches, then I guess that, yeah, fine. It's okay. And also, let me just go to any of the floor plan. Let me just go to first floor, select this, and CS, and draw that from, yes, in this case it is from here to here, and yeah, fine. So first floor, and from here to this point, and from here to this point, and from here to this point. Okay, and just go to 3D, select this, change this to 45, negative, and this to 45 as well. Okay, and all of this, that is 1, 2, and this curtain wall, yes, copy to clipboard, align to selected levels, and to third floor. Okay, and on second floor, I will just draw it manually, saying wall, and that same custom curtain wall from here to here, and from here to this point. Okay, and just go to 3D, that's fine. And change this to 45, negative 45. Okay, fine. And likewise, I'm still not sure about this. So if I just go to any of the floor plan, then if I check this, or let me just take a section, go to that particular section and just see this height. It's 3 foot 6 inches, so it's 6 inches more. Let's change it to 3 foot. And likewise, all this 3 also 3 foot. Okay, and just go to 3D. Yeah, that's fine. Okay, what left is that we need to add railing over here. So first floor, wall, and that same custom curtain wall from this point to this point, and go to 3D, and select it, copy to clipboard, align to selected levels to second and third. Okay, and one, I will just say that 45, negative, and this to 45 as well. Okay, now in order to do the elevation treatment, draft or model the elevation treatment on this particular wall, first we need to add the openings. And also, if you just watch, then here we have this particular curtain wall, corner curtain wall, which is snapped like this. So let's just do all of that. And also, yes, this curtain walls are left. So I will just go to that particular and come to first floor and just say that not first floor, second floor, and just say that CS, and draw that from here to, actually, there is no curtain wall. Yeah, this curtain wall, I made a mistake. This was supposed to be only till here. let's say that select this and just snap it to this point. Okay. And let me just check. Yes, see. So here there are full curtain walls, and here, yeah. Okay, sorry. So that was the mistake I made. Sorry for that. And I will just select this also and delete. Select this, copy to clipboard, align to selected levels to third floor, and okay. And then I will just go to first floor and just say that CS, but this time first floor, I will just say that 6 inch, but unconnected. I will just say that up till second floor with the top offset of minus 18 inches. Okay, and I will just draw it from here to here and select this, change this angle to 0, and change this constraint to second floor with the top offset of minus 18 inches. 3D, and yeah, fine, see, perfect. Okay, so the same thing, we are just going to select this and both of this, and just say that copy to clipboard and paste align to selected levels to third floor. Okay, yeah, doesn't matter. Here I forgot to delete this, so that's why it popped up at error. I just select it and delete it and just say that HR. Okay, so you can just increase and decrease the spacing of this particular mullion, this grids according to your preference. Okay, now what next is that we need to add the openings, door and windows. So I will just quickly go to first floor, and herein I will just say that DR, this particular sliding door sliding double, that is existing a library of Revit that exists within that. So I will just place it on this particular floor. Okay, just say that copy to clipboard, or let's just first place all the door windows, and then we will just with one click snap all of them to the required places. And this door double, first is that the single flush 36 cross 84, that needs to be the toilet door. So you can just add it one, and storeroom, and this toilet, and here, okay, and also this. By clicking space, you can flip between the directions. Then I have this door sliding type B, which I will just host it here. And since it is a parametric door, so it will take a bit of time to regenerate. It's a very heavy file. So just stay tuned. Yeah, fine. So you see that one over here and another over here, and another instance of that with bigger size to here. Okay, and the regular door, this, not this one, this was supposed to be actually less here and here. Okay, and also to here. All this are parameter doors, and here. Okay, and here we will have a simple, or let's say that CS here too, and Here we will have door, which would be this type B, and just put it. Okay. And let's say that window, wherein we will have this fixed louvers 24 cross 24 at the cell height of 6 feet at this location, and here also, and in this location as well, and here too. Okay. Is anything left within this particular floor plate? Let's just check in 3D. Okay, fine. Okay, fine. We don't have any issues. And fine. Now, what I will do is that I will just say that select this and select that your windows has yet to be placed. I guess that. Let me just check. Yeah, kitchen window, kitchen casement window, which would appear over here. So I'll just go to first floor again and WN and the casement window. This 57 cross this particular window, I'll just place it over here and internal conflict with the wall. Yeah, that's fine. Just ignore it. 3 feet. That's fine. In that case, you just need to lower this down a bit, saying it that 2 feet 9 inches that it would have inflect with the wall. But here again, because of its height, I'll just go to here and just reduce this height to, let's say that 5 feet. Apply. And okay, fine. And just select this, go to edit type, and all of this, I'll just turn it to trash, copy, paste, and paste. And just say that okay. Both same, that also paste. Apply and okay. And just say that copy to clipboard. But we will do that once at a go for all the openings, doors, and windows. So I hope that there's nothing left within this. Here also we have that same. Okay, but now I need to go to first floor and WN and select that casement window with slide light and transom. Okay, casement and awning window with slide light and transom, which I will place one instance over here onto this wall and one over here. Just flip the direction, select and flip it, flip it. Okay. 1 and 2, I will just say that what would be it. So already this is 115-inch high. So let's make this equals to 1 feet. Oh, sorry, not 1 feet. 2 feet and 3 inches, 27 inches. Okay, fine. So now let's say that go to first floor and just say that CS and place that window over here also. Yeah. For all this windows, I will just get rid of sunshade. Okay. And the height of this will be 15 inches. Yeah, that's fine. Also, that windows will appear here. So first floor again, and just say that CS and place it here. Okay. Now I will just select entire floor plan filter, check none, and I just select windows and doors. Okay, and just say that apply and okay. So all the doors and windows placed within that particular floor level get selected, and let's say that copy to clipboard, align to selected levels, and just place it to second and third floor. And we might have conflict within some places, but that's okay. That we will resolve it. See, can't place inserts outside of force because this wall at the second level shift to this location. So that's why that error pops up. But rest everything might have been placed. Okay, so see. So what we will do, we will just go to this particular second floor, and wherever the thing is missing, we will just second floor, and at first floor this was here, and at second floor also this is here. So this wall will not come at second floor. Yeah, actually at second floor this will get eliminated. So just CS and place it here, and just delete this and also this wall. Okay, fine. Also, this particular door will change to, because of this elevation treatment, this will change to a smaller size. This decorative, not that decorative. Where is that? Yeah, this is that. Type B and just change it. Okay, fine. Okay, so this is done. And that particular wall I deleted by mistake because that wall doesn't exist here. I mean, at this second level, but it exists at ground floor and this. So I will just go to first floor again. Doesn't matter. And just say that wall, or let's say select this wall. Sorry, select, press tab and select this wall and just say that CS first floor to second floor. Fine. With the top offset of -6 inch, and just draw that from here to here. That's fine. And just say that select, copy, and align to selected levels to third floor as well. Okay. And just say that DR door and select that sliding folding door of type B, sliding folding door window type B. So the greater size. Put it and just say that copy to clipboard, place align to selected levels and to third floor, and okay, and just that. Fine. Perfectly done. No issues. Only thing is that within this particular sliding folding door window, since those are placed inside and are not weather exposed to weather, you need to get rid of this instance parameter show sunshade. Okay, because it is already covered. Okay, fine. So this is how we have placed all the required doors and windows. But now we will have a play within this. For example, this two windows, I will just shift it a bit at this particular floor. Internal conflict with the ball. Yeah, that's fine. Okay, and likewise, this two windows, I will just, or this one window, I will just shift. Okay, for the sake of elevation treatment. Okay, and rest. Now this one and two, I will just snap it here also because this wall is inside, so it didn't copy that window to that location. And both of this, just get rid of, yeah, sunshade is not there, but both of this will have a cell height of 15 inches. That's fine. Okay. And in order to align it roughly, I will just, yeah, this is aligned, just snap it. And yeah, okay. So now it looks aligned. Okay. Yeah. So now what left is the corner curtain wall for all this particular. Okay. And that is an interesting how to place corner curtain wall in Revit. Just join this in order to eliminate unwanted lines. Just have to look view on uniform surface. So with this now, I will close all of this and first go to first floor. Come to this junction, select this, disallow, and with that disallow, I'll just snap it here and this to here. Uh-uh. Okay, what is the problem? Yeah, nothing. And then what I will do is that I will just say that wall, and this time I will just select this corner wall, curtain wall corner dark glass. Okay, saying it, giving it an offset of 3 foot and unconnected 2 feet. And with that, I will just draft it from here to this location, something like this. Let's go to 3D and check. Yeah, fine. It's perfectly appears, but now I will just make this snap go entire till the end. So we have that eliminated and we have this corner curtain wall. See, with this particular junction. And I will just select this wall and move it to this location. Not this, but move this part to this location. That has also, so I will just select this and just say that, or select this. Okay, yeah, let that line be in center, but just unpin this one and two unpin. Both of this I glass I'll unpin, and with that unpin, I will just move it from this point to this point. So that cut remains and move it from this point to this point. Undrawing. That's fine. And 3D. Okay, so this is how you model a corner window, a corner curtain wall in Revit, but you cannot select this particular thing. You can just select this and you see that right now, both of this are, let's say 1 and 2. The base offset is 3 foot. I will just change it to 6 foot. But what you can do is that what you cannot do within this is that you cannot select this and snap it to different level because you have made the changes within the joint geometry of the wall. So you have to do it differently for all the floors. Okay. So I will again come to this particular second floor, and herein you see this wall has been disjoined. Fine. So the job is done. That's fine. But I will just say that wall and corner glass curtain wall. And let me just check if I can just copy it. 1 and 2. Let's say that copy to clipboard. Let's see that whether it works or not. Second floor and just go. Yes. So, see, the curtain wall does exist, but the cut doesn't exist within that particular wall. So that you have to do it manually for all the walls. Let me just change this one. Select this 1 and 2 and just change its base of set to 3 feet. So we can see. Okay. And now within this, you have to perform the cut. So I'll just say that wall and this curtain wall glass pot corner and just select this point 1 to 2 and select this point and 1 to 2. Select this and just drag it all the way. And actually this was supposed to be deleted only. I just kept it because I wanted the reference of this. So I will just say that delete this exterior one, which we made by copy, and this particular thing, I deleted the wrong one by mistake. I was supposed to delete this. Yes, fine. Okay. So now we have to say that why is this not joining? Move it, or let's say that this join, move it from this point to this point, unjoin. This was really tricky, guys. And let me just delete it and just say that wall join disallow. Yeah, the wall disallowed. Then what is the problem? Curtain wall glass corner 1 let's say that from here 1 to 2. Yeah. Okay. Okay, fine. Sorry. So there are hierarchy of steps within this which you need to follow. With this now, unpin this and unpin this as well. Select this and move it from this point to this point. Over the cut has gone. Select this and it has been unpinned. Yeah. So why it is not moving? Yeah, unjoin and cancel. See, I said that there are hierarchy of steps, so maybe this would first need to be snapped here, and with that, now this will move here and join. Okay, fine, done. Okay, and likewise, you have to do it for the third floor also, but right now, just to save time, I am not getting into it. And once placed, you can also snap mullions to that. Okay, mullions to all the grids. And just join this to form one uniform surface. Just to look at balance, I will just copy, align to selected level and to third floor. But don't forget that this is incorrect. You have to manually do it for that particular floor also. And this I will just change it to 6 foot. Okay, and this to 6 foot as well. 6 foot. Yeah, fine. Okay. So with that, now what left within this particular model is only how to create that particular elevation treatment. This particular thing, which I guess that it's very simple. See, I will just show you here itself. HL and just select this, and that is model in place by component. I'll just edit in place this particular thing. Okay, so that is the differently designed 3D elements which has been modeled and snapped to this particular surface of the wall. So this is nothing just a simple extrusion. See, HL. So this is just a simple extrusion with excluding the windows. Okay, and then this particular are the void extrusions created within that particular height of the window. So I will just explain you the concept of this. I just select this and copy this for reference. And with that, I'll just say that finish. Let me see, check that what material had been applied to that. What was the material? Exterior cladding. Yeah, same. Finish. R enter. And just let me just go to this particular file. And here also, there will be 3 windows, which I forgot to place, just as you saw in that particular file. So select this and just go to first floor, CS, and create it here as well. Yeah. Place it. Just copy to clipboard, align to selected levels to second and third. But on second floor, we will just shift that to this end. And we will have staggering of windows in order to have that particular elevation treatment. Okay, and now I will just quickly show you that how to create that particular elevation treatment. So for that purpose, I will just go to ground floor, and herein I'll just draw a reference plane. It's already there. Fine, no issues. And with that, I will just say that PK, pick a plane, pick this particular plane, and either go to section 1. Yeah, go to section 1. Okay, and with that, now I'll just come to architecture, component, and model in place. And since it is going to be elevation treatment, so I'll keep it in the category of walls, and I'll just call it elevation treatment. Okay, and you are in the drafting mode. You are in the drafting mode. So just create this extrusion, create this entire part till here, snap this lines. Okay, eliminate so much part and you have now overlapping lines, that's fine. Also snap this here, and eliminate this line as well. And likewise, select this, copy it from this point to this point, and just say that split 1, 2, and 3. Join this to this, join this to this, this to this, this to this, and likewise this to this and this to this. Okay, and just adjust it according to your preference and design. Okay, so this is the elevation. Let's keep it 15 inches, and the material would be which cladding? Exterior cladding. Okay, but that was not the one that was in that particular file. Which was the material? Okay, right now let's not worry about what material do we reference. Select that only, exterior cladding, and just click OK. Why is that not selecting? Okay, let's select this. None of the elements and none of the materials are getting selected. Okay, fine. Let's see that finish. Go to 3D. So you see that that particular shape has been created. Okay, and just say that finish. And let me just press save. And then let me just go to edit in place again and go here. And why is the material part not working? Brick 2, brick cladding. Oh, this is really, I will just say that finish. Let me just reopen the file. So I'll just take pause this recording for a second. Yes, I'm back. So Revit sometimes behave unexceptionally, unexpected, and I'll just go to edit in place. And now if I just select this and go to this particular material part and apply this material, then it will perfectly work. Okay. And if I just go to this particular section 1, and here I will just select create and void forms and void extrusion. So I will just roughly say that deduct so much of the portion and copy it multiple times with multiple checked on. Okay, I'll just place this one and CEO, copy it multiple times. One, I snapped it wrong place. CEO, 1 to 2 and 3, 4, 5, 6, 7. And let's select all of them, CEO, and yes. Okay, and just adjust it a bit according to move it from this point to this point, and you will have one more over here that completes it. Okay, and if not, then just shift it a bit. Okay, that's okay. Or let it be and select all of this and move it a bit down. That will look proportionate. And go to 3D and just say that extrusion start and extrusion end finish. So I guess that we need to click negative. Okay, and with that, I'll just say that. Okay, so you have created that. Okay, this ways you can just select all of this and just say that CEO, copy it from this point to this point and this point as well. And all of that has been created. Wireframe, and just select this chunk and just move it a little bit and adjust it. HL. Likewise, select this and just adjust it. Okay, and go to 3D. Okay, and once this one is done, what you can do now is that you can select this entire thing and just mirror it here. Go to this section and just DM and mirror it. Okay, and then once mirror, you just need to adjust it a bit according to the placement of the window, the snap points, and just say that okay. Okay, and this window, now you need to shift a bit according to this, the placement of this. Okay. And select this particular window and move it from here to here. And this particular thing, I guess, yeah. So this you will have to copy it again. Okay. But I hope that you understood the concept of this. Edit in place. Select this. Fine. Let's just do it. Copy it from this place to roughly this place and roughly this place. Select this and just move it. Select this and move it. And it's done. Perfect. Okay. And the same thing, you have to copy it here on this side. So let's just select this, go to ground floor, DM, and mirror it. So is it mirrored here? Yeah, fine, it is mirrored. Okay, and then just adjust it according to your placement of windows. Select this and move this point to this point, and then adjust this window, the location of this window. But in order to adjust that, you need to finish the model and then just move it. Okay, and it's done. Now I hope that you guys know how to create these grooves by void extrusion. Okay, fine, simple. So with that, we are completely done with the modeling part of this G+4.5 residential building. Wherein some loopholes, I guess that this is not matching actually. Let me just check the seal of this is 2. Oh, sorry. The seal of this is 2.11 and this 1.3. So all of this I will just select 2 feet 11 inches, 2 feet 11 inches, and likewise 2 feet 11 inches. With that, now I will just come here, edit in place, edit, and change this location from here to here. Okay, and with that we are done. Okay, let me just go to ground floor, and herein, if I go to this bulb and unhide in view by elements, snap this to ground floor and just go to ground floor and say that where is align this to this. Okay, and with that now you can draw the compound wall and elevate the site, and site is nothing but just the extrusion of different floor plates. See, if I just it is group, I just say that ungroup, and it will take a bit of time. Just stay tuned. Yeah, see, this all of this is nothing but just a floor plates given that particular material. Okay, the AutoCAD plan has been extruded. Okay, no other rocket science in that. Fine, and this is the wall, the compound wall, the profile of which is edited. See, this is the profile of the wall which it is following, within which I have eliminated, created these grooves. Okay, and here I have snapped this extra wall in order to create a flower bed. Okay, so that's pretty much simple. Clear? And how to add this particular elements. So in order to make you explain that, let me just do one thing. Let me just click undo a couple of times. And until this is one complete group. And I will select this group. And I'll just say that copy. But I cannot copy because that is in different. I will just say that file and open up that live project April 25 batch, which is yet to begin. The first week of April it will begin. So let it open. Just take a bit of time and just say that yes, continue opening the file and select this and just say that copy. And with that copy, just come to the ground floor plan and just paste it here. And just say that okay. Just paste it. And once pasted, just snap it to the perfect location. Okay. And yeah, the site has been copied. What you need to create is the compound wall. So I'll just say that compound wall, and that is also ready, I guess. Main wall, compound wall, and edit brick cladding 2. This was not the this, I guess, and wall to be finished with exterior and 0 and unconnected to, let's say that 8 feet or 10 feet or whatever as per your preference. Just draw it from this face to from here to अरे कौन सी wall है ये? This is another wall. Oh yeah, fine, sorry. So actually that one, the wall which I selected earlier, that was the wall which I was supposed to create, and 1 to 2 and 1 to 2. Okay, and just go to 3D. This is the completed project. This is our project. R enter. Okay, clear? Fine. So we are completely done with the project. And now how to add those particular elements which exist within this project. That is the car, trees, the street lights and all that. So that I'll just show you in a while. Just go to architecture and component and place a component. So from that you can load all the different types of trees that exist within the environment of Revit. Okay, as per your need. Okay, apart from that, if I just go to insert and load family, you have here lots of existing libraries of Revit which you can load: English, Imperial, US, and from that entrage, and you will be able to load this particular car, beetle car, male, female, everything, and all the other components. So now if I just go to CM, I can host human figures to this. Okay, and also this car, parking space if we want in this particular car. Why I'm not able to select the car? This is getting selected, but this is not getting selected. Let me just click H. Yeah, just click space. Fine, HR. Oh, this is the female sitting. We don't want her to sit, we want her to stand. Yeah, fine. Okay, so we are completely done with this particular project. The only thing left now is to snap that particular exterior materials to the element, to the 3D element for its elevation treatment. So just go to modify, and herein you have this option paint. From that, I will just select this particular brick cladding, apply it to this entire wall. It selects, but we don't want it. We want to place it to certain part only. So what we will do, we'll just go to modify, and here is split face. Okay, so within this wall, I want to split its face. So this yellow orange line appears. So just draw this particular line from this point to this point, and likewise from here to here. You just need to follow the snap points. Okay, So this is now splitted. It should actually touch. It should actually touch this particular orange line. Yeah, sorry. And just say that finish. No, yeah, here it is. Here it is not connected. So that's why. Okay, finish. With this now, even though this is one complete wall, you can assign a different material to this. So just come here and apply this material of brick cladding. That's perfect. Okay, and likewise, you can apply a different material to this faces also, which is already splitted. So come here and this exterior cladding, I'll just apply it to this entire face, which we don't need to split, and this wall also. Clear? So now it matches. Okay, you can just create a split face and draw a line over here in order to apply continuous material. Fine. And that is how I have applied this material to different areas. For example, you can see that here that material has been applied at the same time here also, and likewise here too. Okay, with the help of that particular split face. Fine. So with that, we are completely done with the modeling of this particular structure. Only thing is that we need to provide the railing over here. So I'll just say that select this and go to third floor plan and just say that CS. And with that, I will just draft that particular railing from this point to this point. No, that is actually a wall, entire wall. Which floor it was? Yeah, it was third floor. Yeah, fine. So just say that wall, and from here to here, and CS. I would say that wall from here to this point, and here to here, and just go to 3D. Fine. Okay. Clear? So this is how you can model 3D elements in Revit and create this. And once done, you can export to any of the render engine, for example, Enscape, Twinmotion, Lumion, or anyone, Blender, D5. There are a lot of them. Revit is not a render engine. It is the technical software meant for perfect modeling of the 3D element with perfect precision and perfect joint condition. Fine. So you just watch this video and you can type down your doubts and queries in the comment section, and I'll try to reach out to you, each one of you individually, solving your doubts and queries. And if you think that this particular video was worth, then kindly enroll for this course and let's learn together and let's grow together. Okay. Bye everyone. Thank you.